Cool. So we are live now. Hello everyone. This is Umang here. I am from Elite Techno Groups. You guys know me already. So with us, Karthikeyan has already joined. I believe it was already a great session yesterday, and you guys got to learn a lot. With today's session, we are starting a few minutes early. The reason being that so that you can ask yesterday's doubts today and we can clarify those. And once those doubts are clarified, we would be jumping on to the next day's or today's learning. So let me give you a quick walkthrough on today's event also. Okay, so we will be taking the project which is there, where you will be hands-on executing certain ML learnings and concepts. Once that's done, we would open up for doubts, and soon after that we will open up for the scholarship test. Scholarship test will be there for 10 minutes. Okay, right after scholarship test we will be having another session by Dr. Dipan Sahu. He is an AICTE executive member. Okay, and we would be closing the session then. So today going to be a 2 to 3 hours of, or rather 3 hours of sessions approx, but that definitely would be good learning. So 2 hours of learning with Mr. Karthikeyan, and then around 30 to 40 minutes of learning with Mr. Dipan Sahu. Byte is officially ending tomorrow. Tomorrow we have Mr. Sahil Agarwal joining us from US. Okay, he works with a US startup called Abnormal Security, and before that he had worked with Walmart. So he would be joining for a session tomorrow. So this is how the session, and that would be again on machine learning. So today's machine learning concepts you learn. Tomorrow it would be more on pipeline, machine learning, project management and all that, which would be more on understanding concepts. So without any further delay, start asking doubts. We will start picking up the doubts, and Mr. Karthikeyan will be resolving them. So please shoot.
Yeah, thanks, Umar. Okay.
Karthikeyan, shall we do this? Shall we take a quick recap of yesterday in 5 minutes? And I don't think many doubts are there anyways. So shall we just jump on to with the review and then move on to the next things?
Yeah, sure, that also works.
Cool.
So welcome everyone again. Yesterday, we saw about artificial intelligence, and mainly, our focus yesterday was that anybody who's not aware of machine learning or artificial intelligence before should be able to just jump on the vehicle and start learning it. So that was the way we designed these two-day course, right? So as part of yesterday, initially we started with what is artificial intelligence. Then we spoke about what's machine learning, what's deep learning, and what is the difference between them. And then we deep dived into what are the different types of machine learning that is available. And then we moved on to the machine learning life cycle.
And the main reason behind is to give you a exposure of how an actual project gets executed. Okay, so actual machine learning project or a data science project, how it gets executed in a project environment. So to give you understanding of that and how the mechanics work, we talked about in brief about the different phases in machine learning and what happens in each of those phases. So we took an example of the retail, where we started from business problem definition, then data collection, the data processing, the exploratory data analysis, then building the model, evaluating its performance, and finally deploying the model and monitoring it in production. So we saw the entire cycle, and we also saw the different roles available in machine learning, right? So we saw like what are the stages, and in each stage who is the actual owner of that stage, right? So who is performing the action on that stage. And we also saw the different skills that are required for each of those roles, so that when you plan a career in machine learning, like what are the different roles that are available and what are the skill sets that you should acquire for having a successful career in it. So that's what we saw yesterday. And today we are going to see a real-time example where it's about an automobile company. You just think that you are being hired by a global auto company, and they are entering newly into a market. Say like a Chinese company getting into Indian market, and they have to set a price for their car. Okay, they are manufacturing and they are getting a new, so they will do a market analysis, right? So they will get all the information about the existing cars in India, at the price point at which they are, what are the features that they are offering, and based on that they will compare their own product and decide like what should be the actual price point for their car. So that's what we are going to do. You are going to suggest like what should be the right price for the car, and we are going to do this use case using linear regression. So in yesterday's class we saw about different types, right? And the first type we saw is like supervised machine learning, and within that the first type we saw is regression, right? So we draw a regression line matching the input distribution. So that's what we are going to do. So in today's session, I will talk about what is linear regression, how it works. I'll give you a few examples of other linear regression use cases. Then we will say about the math involved behind linear regression, so that you have a deep intuition of how it works. Then we will jump in to coding. Okay, so I'll share my notebook with you guys, so you can download it and run it by yourself parallelly along with me. So the notebook is divided into two sections. In the first section, like we will build a linear regression from scratch. So without using any library, we are just going to implement whatever we studied or understood the math behind the linear regression. We are going to use that knowledge to build a linear regressor from scratch. And then the second part, we are going to download the data set that we are going to use for predicting automobile price. And then we are going to build a linear regression to predict the price from it. So that summarizes like what happened today and what we'll be doing in the first 2 hours of day 2. So maybe before getting started, like if there are any queries, like you guys can post it on the chat here or on the YouTube live also. I'll take up a couple of questions if you have, and if there are no questions, we can get started with the session. Okay, so I see a question. Somebody asking about outliers. So I think we haven't discussed any topics yesterday or today so far about outliers. So I assume that your question is based on your prior experience. So outlier is nothing but just like the name says, it's something outside, right? Say you have a distribution where 90% of the values lie between 1 to 80, and say like there is one value which is having a value of 250 or 260. So that means that your normal distribution is between 1 and 80, and you have certain points which are way beyond that, right? Like 200 or 250. So now the point which is there beyond the distribution, the 250 or 260, is called an outlier. So meaning they are out of the normal distribution. And why they are important is like they will give you certain interesting information about your distribution, or it could be a error also. So you need to evaluate whether your outlier is an actual outlier or it's an error in while getting your data. So if it's an error in data, you are going to fix it, or if it's an actual outlier, then they will give you some interesting information about your data. And I'm getting another question: what are support vectors in SVM? So again, I think this might sound out of context for other people because we never discussed about SVM in yesterday's or today's session. But in general, what a support vector does is it maximizes the distance from the data points on your regression line. So SVM is also like your linear regressor. Say you have a linear regression, you can have multiple decision boundaries. It's just not that you have one decision boundary for a problem. Multiple decision boundaries are possible for one problem. And how do you select which is the best from it? So that's when support vectors come into picture. Your support vector help to have the decision boundary that is having the least error rate and has the maximum separation from your data points. And then there's a question: semi-supervised learning is also a type of ML. Yes. So semi-supervised is also a type of ML. So semi-supervised, what happens is, say you have data where you have certain data points which have labels, and there is another half where you do not have labels. So based on the ones that have the labels, you create a classifier or a regression model that's going to predict the labels for the rest half. And then finally you use the entire data set to build the final model. So it's like, you are going to have two models, one for labeling the data and then one for predicting the use case based on your need. So I think the questions have stopped coming, we had only 3.
The YouTube video. One, I think few people might be interested in how to use the GitHub with Colab. Many people might have concerns with that. So I think that, because few people have asked about that. So yeah.
Okay.
Yeah, fine, Umang. So maybe I'll get started with linear regression and then show about how to use Colab through GitHub. So maybe I'll quickly get started with the session since we are also limited by time. So let me share my screen first. Okay. So I'm sharing an Excel sheet with the participants just to show how what is linear regression first. Okay. So just like the name suggests, linear regression means that you have a linear relationship between two variables. Say in real time, there are a lot of places where a linear regression can be applied. So for example, you have house price prediction. Okay. Say you want to predict the price of a house, then say you have the area of the house. Okay. So now as the area of the house increases, okay, the size of the house increases, your price will also increase, right? Say you have a half ground house and a 1 ground house, then it's going to double up the value, right? So based on the square feet of your house, the price of the house is going to keep on increasing. So there is a linear relationship, right? So as the size of the house increases, the price also increases. So that's called the linear relationship. And the other example could be like, growth of plant with respect to sunlight. So as the amount of sunlight increases to the plant, the growth of the plant will be higher, right? So that could be another example. And say like, hours spent studying with marks scored by a student. So as the number of hours spent studying increases, the person will also score more, right? So you have a linear relationship again. So whenever you have a use case like this, okay, so where you have a linear relationship between two variables, we can apply linear regression there. So to give you a visual representation for you, like I'll share, I'll quickly plot these three, distributions in a graph, and will show you how it works. So first I'll start sharing my entire screen so that when I juggle between different screens, you will be able to follow. So what I'm doing is like I'm just copying the data points, and I have a graphing calculator. So this is an online graphing calculator used for plotting graphs. So I just paste it here. So now you can see that, this is my x-axis. So I have 0, 10 here, and this is my y-axis. I have the price point here. So for 1, it is like 158. For 5, it's 589, so on. I have a linear relationship here. And similarly, I'm going to copy the other two items. So I copy it, and I copy the third one also. So here, if you see, this is very zoomed out, right? So you do not see the linear. So I'll just zoom in. So here you can see that there are 3 plots now. One represented by green dots, another represented by red, and the other represented by blue. So now, though they represent different distributions, they are all linear, right? So you can see, like, as the x-axis increases, the y-axis also increases. Now in linear regression, what we are going to do is we are going to use a hypothesis called y is equal to mx plus c. Okay, and almost every one of you would be aware of that equation, right? Y is equal to mx plus c is the equation of a linear line. So I'm going to put up the formula where I'm going to say my line is going to be mx plus c. Okay, and I add slider. So what it does is like now you see a green line, right? So that's the line that gets generated, and now I can vary the value of m and c. Okay, so m represents slope of the line, right? So when I vary the slope of the line becomes more and more slanting and goes to the negative side. This is positive, and when it goes below the axis, it's negative, right? So when my m value is minus 10, the line looks like this. And when my m value is like positive and 10, it looks like this. So by varying the value of slope, I can vary the tint of the line. Okay, and c is nothing but where your line passes through the intercept. So in our example, it's passing here, right? So this is where my line is passing the intercept. So if I vary the value of c, you can see that the place at which my line passes through the intercept changes. So when my value is equal to 0, it just passes through the axis, right, at 0. And if I make it 1, then it's going to move to 1. And if I make it minus 1, it's going to move to minus 1, and so on. So this is what, we can do with a line. And say I want to model this distribution, the blue distribution that we have. Then that is possible, right? So I just change the value of m. Now if you see, it directly maps with the blue dots, right? So now my equation mx plus c maps this distribution, the blue distribution. And the same equation mx plus c can be used for modeling another one as well. Say, I change this and I make this, somewhere around 50. And then I change the value of m. Now it is perfectly fitting the red distribution, right? I haven't changed the hypothesis. My hypothesis is still mx plus c, but by changing the value of slope and the intercept, I'm able to map a different distribution. Similarly, if I go on to change this one, so this is like 300 somewhere. Minus 300 and 300. And now say I change it. So now this is aligning with the green lines, right? So I zoom out. Now you can see that it's becoming more and more closer with the green distribution. So with just this equation, I can any relationship that I have, any data set that I use, if it has a linear relationship, I can use this equation mx plus c to model it. So this is what we are going to do. And now you may get question like how we are going to get the value of m and how we are going to get the value of c, right? So that becomes the next challenge. So let me explain like how the math works behind it. So I go to the meet. So do I have the Jamboard? Okay. So I'm just opening a Jamboard so that I can write it on the screen. Okay. So let me draw a diagram for you first. So this is not very clear. So I'll use my epic data set. I have this. Okay. Say for example, now I have a graph like this. Okay. So this is my x, and say this is going to be my y. Okay. So this is my x and this is my y. Say I have a distribution like this. Okay, so I have some data points like this. Now I need to draw a line, a regression line that matches this data, right? So I'll draw a line like this. And now in this graph, this is my line and these are my data points, right? So say I have different data points now, and now this point will be represented as y1, right? And this is going to be my y2, this is going to be my y3, this is going to be my y4, this is going to be my y5, y6, and so on. So I'm going to have multiple data points. And now this is perfect fit, right? So my line just passes through this line. So here my error will be 0, right? So if I calculate the difference between my predicted point and the actual point, it becomes 0. And if I take this line, there is a difference, right? So there is a minor difference between this point and this point. And now this will become my y2 dash, or where I predicted, and this becomes y2. And my error rate is going to be, my error for the second point E2 will be y2 dash minus y2. Okay, say this y2 was, I'm just assuming, okay, say this was 1.8 and say this point was 2, then this difference will be like 2 minus 1.8, my error will be like 0.2, just for illustration purpose. Similarly, like, from this point to this point, right, I have a minor difference, right? So this difference is the error rate for 3. So my error rate 3 will be like this difference. And similarly, like, for 4, I have this difference. 5 is almost closer, and 6, I have a difference. So like this, at each point, we calculate the difference between what is predicted and what is actual. Okay, so the difference is called an error. And we calculate error for each point, and this is called a residue. Okay, and now your objective is that for all the data points, you should have the least amount of residue, right? So our goal is that the error should be very low, and for that you need to reduce the residual amount for each of the point that we have. So we will see how we are going to do it. And let me draw another graph which is quite bigger in size. Say I have a data point like this. Okay, say I have some data points like this, and let me share the colorful. Say I draw a line like this. Okay. Now, slope is nothing but the slope of the line, right? So, and slope is usually given like this, right? Say I have 2 points like this. My slope, say like this is x1 or y1, this is x2 y2. Then my slope value will be y2 minus y1 by x2 minus x1, right? So difference in y value by the difference in x value will give you the slope. And say you have a steeper curve, your slope will be high, and if it is lower, you're going to get a lower slope. And intercept is the point where it cuts your axis, right? So this becomes your intercept or the c value. Okay. So your c value will be the point where your y value becomes 0, or your equation is equal to y is equal to mx plus c, right? And the c point is where your x value becomes 0. So this is your x and this is your y, right? So when your x value is equal to 0, your y meets the c value, right? So when you replace your x value with 0, then m into 0 will become 0, right? So your y value will become 0. So basically, when you meet your x axis, or when your x value becomes 0, your y value becomes c. And for illustration purpose, okay, for the sake of simplicity, what I'm going to do is, like, I'll take one graph where your c value is 0. Okay, so let's assume that my c value is 0, so that I can find the value of m. So for that, what I'm going to do is, like, I just assume that I have a certain plot where my c value is 0. Okay, so I have a graph, say, like, this is 1, say this is 2, this is 3, and this is 4, and similarly this is 1, 2, 3, and then 4. Okay, say I have a point like 1 comma 1, say I have a point like 2 comma 2, say I have like 3 comma 3, and 4 comma 4. Now this line will just pass through my axis. Okay, say I have a point like this. Now we know already that my y is equal to mx plus c, and now in this case my c value is 0 because it passes through the axis. So now this becomes like y is equal to mx. And since this is a predicted value, the value that we are predicting, what I'm going to do is, like, I will just represent it as y dash. Okay, for easier understanding. Now we have 4 data points, and now I need to calculate, at each point, what is my predicted value, right? Say, like, now if my m value is equal to 1, okay, say I consider that my m value is 1 for iteration 1. Okay, I do my first iteration, I consider my m value is equal to 1. Now my y1 dash, or this is the first point, right? So this is the first point, I'll say I call it y1. And now my y1 dash is nothing but m into x, and since I consider my m value is 1 and x value is 1, so this becomes 1 into 1, and the value will be 1. Okay, and my actual value is also 1. And if I calculate for y2 dash, then it becomes again mx. Here my x value is 2 and my m value is still 1, so this is 1 into 2, so I get the value as 2. And similarly, if I do it for y3 dash, it becomes 1 into 3, so I will get like 3. And if I calculate as y4 dash, then it will be 4. And in this case, when I calculate my error rate, which is like y dash minus y, right? So at each point, I will calculate my predicted value from the actual value. So here my predicted value is 1, and my actual value is also 1. So my error will be like 1 minus 1 will become 0, plus 2 minus 2 plus 3 minus 3, and so on. So my error will be 0 when my m value is equal to 1. And similarly, like, I can calculate for m is equal to 2, m is equal to 3, and so on. Say, I calculate my m value as 0 for simplicity purpose. Now, if I do y1 dash, m into x will become 0. And if I do y2 dash, it will also become 0. Y3 dash, it will also become 0. And y4 dash, it will also become 0. Now, in this case, if I calculate my, error rate, then it's like, 0 minus 1 the whole square plus 0 minus 2 the whole square and so on. So I'll get like 1 square plus 4 plus 9 plus 16, right? So it will be like, 16, 25, 30. So my error rate will be very high. And similarly, like, if I do 0.25, m is equal to 0.1.5 and so on. What happens is, like, say I make a graph and say, I have the error rate here. And I say, like, I have the m value in this axis. Now, when my m value was 1, right, say my m value is 1 here, I got the error rate of 0, right? So my error was 0 when my m value was 1. And similarly, when my m value was 0, my error rate was, 30. And if I plot it for 0.5, my value will be somewhere around here. And if I do it for 1.5, it will be like here, here, and so on. And if I plot this function, right, my error rate function in terms of m value, then my slope, will look something like this. Okay. And in most cases, in linear regression, instead of directly taking the error, right, just the y dash minus y1, we go for something called the cost function. Okay. And cost function is usually calculated like 1 by 2m summation of I equal to 0 to m y dash minus y the whole square. So it's pretty similar. Like for error term, we use this, right? Like just y dash minus y the whole square. For that, you take the average 1 by 2m, it becomes a cost function. So this is the most commonly used cost function for linear regression. And if I plot this cost function, this is how the graph would look like. And your objective is to reduce the error, right? Error or cost function. So, when you have a curve like this and you want to reduce the error function, we have something called a gradient descent. Okay. So we use a gradient descent algorithm for reducing the error rate. And how we are going to do is like from the peak point, you have to reach to the lowest point, right? Say you might start here or you might start here or wherever you want, you can start your iteration by taking different value for m. Okay. So based on the value that you take, your objective is to reach to the lowest point, right? So for that we use gradient descent, and gradient descent in general is described like, say, you are blindfolded and you are on top of a mountain. Okay, so this is like a mountain, right? Say you are on top of a mountain, you are blindfolded, so now you want to reach to the lowest point in the valley. Okay, so how do you do it? You just take one step at a time, right? So you take a step from this point and you see whether your step is decreasing or increasing. And say, like, when you set your foot up and your slope is reducing, you know that you are going the right direction. So next you go a little more, a little more, a little more, and so on. So you keep going like that, and you will reach a point where the slope starts increasing, right? So until this point your slope will keep reducing, and from this point if you move on, your slope will increase. So at that point you stop and ensure that that this is the lowest point that you have. So now this method of taking or updating one step at a time and calculating your error rate and deciding whether you are going to stop your iteration is called gradient descent. Okay, and how it is done is like using an algorithm where you are going to update the m value and c value. Okay, say I represent m naught as the iteration 0, and my value is m naught here. And then in my second iteration or the the next iteration, my m1 will be like m naught minus alpha of differentiation of my cost function with respect to m value. So what it says is like now say my m value is from previous iteration. I'm going to update it with alpha is called the learning rate. and you have the cost function, right? Cost function is nothing but the this definition that you have, and you are going to differentiate it with respect to the m value. Okay, you are going to calculate what is the change in error rate with respect to your slope, and then with that value you are going to multiply the learning rate. A learning rate is like determines how much step you need to take. Say you have a cost function like this. Now you can either take a step like this, or you can take a bigger step like this. And this difference, for this it's a smaller step, right? And you can also take a bigger step, or you can even take a bigger step like this. So the size of the step, right, so can be varied, and the size of the step is usually determined by the value alpha. So if your alpha value is very high, the step that you take will also be very high, and if your alpha value is low, then the step size will also be low. So your alpha is called a learning rate. Just like the name says, it determines how fast you are going to learn. Okay. If the alpha value is very high, your value is going to move much faster. And if your alpha value is low, it's going to move much slower. And based on this alpha value and the differentiation of your cost function, you are going to update the value of m at each iteration. And this is called a gradient descent. So I think that was too much math. Maybe if I can take up some questions before proceeding. If you guys have any questions, just post it in the chat, or in the YouTube link also, so that I'll answer a few questions, and then I'll walk through the code. So Umang, if possible, you can open the chat in the YouTube also. I'm getting one question. What is the difference between supervised and unsupervised? So I think this is from the yesterday's session, right? So supervised is when you have a label. So you have a target label in your dataset, it's called supervised. And when you do not have a target, it's unsupervised, meaning like you do not have a target. Then I have a question. What is the error rate? Why we have to calculate? Okay. So, in the Desmos graph I showed you, right? Like initially when you start, you do not know where your error rate is, or the distribution is. So initially you have some value for M and some initialization value for C. Then you plot the graph and you calculate the error rate. Okay, and once your error rate is found, based on the error that you see, you move the graph, or you move the regression line closer to the data point. Then again you calculate the error and you move it again. So the process keeps on going, and your objective is to reduce the error in your distribution. So I have a question. Can you explain what is naive in naive base? So again, naive base is out of context for most of the participants today, since we did not discuss about it. But naive, we call it because we call a child as naive, right? So naive means you do not know. You're very innocent, and you do not make any assumptions. In naive base, what happens is like you keep updating the posterior probability based on the new evidence that you find, right? So when the classifier starts, initially it doesn't know anything. It sees some evidence, based on that it updates the posterior probability, then it recalculates. Again, when a new evidence comes, again it updates the posterior probability, and so on. So that's why we call it naive base, meaning like when it starts, it's very naive. Okay. Yeah, yes, Umang. We have a couple of more questions in the chat. So one of them is like if the points in graph are scattered, then we will use different algorithm to solve it. So yes, so when there is a linear relationship, only linear regression will work. So if there is no linear relationship, linear regression will not work. So one thing is like you need to see if the factors that you are considering is wrong. Okay, so if they are really correlated or not, so that you need to do. And even after correlation, if there is no relationship between the two variables, you cannot apply linear regression. And then please explain gradient descent a little bit with the equation and what its proper definition. Okay, so maybe when I do the walkthrough, I will take up this question. I'll when we I have certain images to understand better. So when we go to the code walkthrough, I will emphasize on this part. And there is another question: why is machine learning emerging so fast? Again, machine learning started around 1980s, right? So we saw in the slide yesterday. And why it is emerging currently is due to the availability of data. And they used to say like the first NASA mission to moon, right? So it's called Apollo mission, and the computer, they used computers there as well, right? There was a computer which was powering the Apollo mission, and a typical iPhone 5, right? So not even 10 or 11 that we use now. Much predecessor iPhone 5 processor is like 100 times faster than the computer that was used in Apollo mission. So that's the kind of processing power that we have today. So the data that we have, again, with emergence of Facebook, Instagram, and all that, we have explosion of data, right? So we have a lot of data, and machine learning needs it. We have a lot of processing power, and again, machine learning needs it, right? So the availability of data, the cost required to store them has come down radically, and the cost required to process them has come down radically. And these are the three main factors which are leading to a lot of developments in machine learning and deep learning. So in that, Umang, I have answered all the questions on
the chat. Maybe you can read out a couple of questions from the YouTube, and then we'll proceed.
Cool. So one of the first question asked, so a lot of people have asked about gradient descent. So that is one thing. Then, as you said, you will be taking it up again. So some people have asked about cost function. People are confused about cost function.
Okay.
Yeah, like along with the notebook,
I will explain.
What is linear regression in general? Is it something different from plotting values?
Okay. Not plotting values. Say like it's we are just trying to any algorithm. Okay, you take it will have a hypothesis. Okay, so for linear regression we take equation of a line, right? And this is only simple. Okay, so we have three types of linear regression. The first one is called simple linear regression. So whatever we have seen, right, y is equal to mx plus c, that means it's a simple linear regression. You just have one independent variable, and that's also linearly distributed without any polynomial. And second is called a multi-linear linear regression, where you have multiple independent variables and one dependent variable. And then we have polynomial regression, where we have higher dimensionality to the input, like x square, x cube, and so on. So we have a higher dimension, being used in the hypothesis for polynomial. So since simple linear regression is easier to understand, like I took only example of simple linear regression, but I will show you the equation of the other types when we get to the code.
Cool. The next question asked is, what is the intuition behind differentiating the cost function?
Intuition behind? Differentiating. Okay. So, in our example, we had only one variable, right? So I had X, Y. But in real time, there will, be many columns, say 8 columns, 12 columns, 16 columns, based on the use cases that you have. Now, your cost function will be dependent on multiple variables. Okay. As a human, it's easy to understand two-dimensional graph, and we can understand 3D is what is the max, right? If I give you a data which has 4 dimensions, as a human, we cannot comprehend it. We are only limited to three-dimensional space, right? We can understand only 2D and 3D. That's why we took only two, variables, because it's easier to show it in a two-dimensional graph. Say, like, you have 4 variables or 5 variables, then the dimension increases, so your plot will also be in 4D or 5D. And when you do the cost function analysis, now your cost will be dependent on all the 4 variables, not just X. Say you have X1, X2, X3, X4. Now your cost should also be distributed to X1 separately, X2 separately, X3 separately, and X4 separately. So we use partial differential equation. So why partial? Because I want to compute what is the impact that just X1 has on the cost function. Then what X2 has on the cost function, and what X3 has on the cost function. So to do that, we use partial differentiation of that particular variable. So that's the reason we use partial differentiation there.
Next question asked is why we approach local minimum in gradient descent.
Okay. So global and local minimum. Maybe I'll share my screen to explain that. So local minima is like, say my cost function is like this. And this is an ideal cost function. Okay, so if this is like this, it's very good for us. And but it is not always a U-shaped curve. Your cost function can also be like something like this. Okay, so what happens is when you have a learning rate, in this case, say, like, I drop from here to here, 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 and when I move on, it increases, right? So I stop here, so I go to the least point. Okay, and for this graph, this point is both the local minima, it is also the global minima. Okay, both are same for this distribution. Say I have a distribution like this, and here I again use gradient descent. I go on like this, and say, like, here the slope increases and I stop here. Okay, now this is called the local minimum. So at this curve, this is the minimal point. So this is called a local minimum. But if I take the overall curve, this is where I have the lowest point, right? So this is the global minima here. So for this distribution, we have two different points. This is a global minima and this is a local minima. And there is a risk that when you have a smaller learning rate, your local minima Okay, so I think I unmuted now. Until what I was audible, Umang, so that I can repeat it. Okay, okay, thanks, Umang. In cases like this, where we have a local minima and global minima differently, when we have a shorter learning rate, there is a pitfall that we may capture the local minima instead of the global minima. So this is what is the difference between local and global minima. And there are different ways in which we can escape this. One is like, a learning rate decay. So I'll just talk about this alone because the other topics are quite advanced and may not be appropriate for this session. So I will talk about learning rate decay alone. So here what happens is, say I have a value alpha value of point not one. Then what happens is, like, this will not be stable throughout. Say, like, I have 5,000 iterations. What I will do is, like, from 0 to 100 iteration, I will have this value as 0.0001. And for iteration 100 to 200, now this value will reduce. Okay, so I will make it like 0.00005. And then from 200 to 300, I will make it like 0.00001. So I will keep on decreasing my learning rate as the iteration increases. So this is called learning rate decay, meaning my learning rate reduces as it goes on. And what happens is, like, initially I will have bigger steps, so like this, so that it will drop away from the local minima. And as it proceeds, my learning rate will come smaller and smaller, so that I can achieve the global minima. So that's the concept behind learning rate decay, and it is used for escaping from local minima. And there are other techniques as well, but I think they are beyond scope of this session.
So I think shall we just take one last question and continue with the content?
Yeah, yes, no.
So there's one student who has asked about defining the jump on alpha. How can you explain how jump is dependent on alpha and what is alpha here?
Okay, so I think most of the questions are flowing around gradient descent only. So say this is the value I have. Okay, so this is my m value and this is my cost function, and I have the slope here. Okay, say I have a curve like this, and now I make the steps, right? Say I start from certain point, I make the step. Okay, say this value is 0.5. Okay, when I multiply it with zero point 0.1, now this value will reduce. And say I multiply it with value greater than 1, this value will go up, right? When I multiply it with value less than 1, it will come down. So you get, right? So based on the multiplication factor, I can change the value irrespective of what is the step value. And if you see the gradient descent algorithm, what we are doing is, like, the new value of m will be the old value of m minus alpha into differentiation of the cost function and with respect to m value, right? So this becomes this 0.5, right? So this is going to be constant when I have a cost function. For that, what is the impact that the m value has, that I'm going to calculate as a cost function. This is going to be the standard. And now this alpha is the hyperparameter. Now I can set value for alpha, right? If I make alpha as 0.001, now this 0.5 will become like 0.005, right? And if I make it 0.002, now this will become 0.0010, right? So irrespective of the cost function, I can impact the step value based on my alpha rate or the learning rate. So that's how we use the learning rate, and that's how it impacts the step value. So for larger alpha value, my step size will increase. Say this is my cost function, and if my alpha value is higher, since I multiply it, my step will go like this. And if I make my alpha value smaller, my step could be somewhere smaller than that, or smaller than that, and smaller than that. So I can determine the amplify or reduce the impact of the cost function by changing the value of the learning rate. So I hope that answers the question.
That also. So I think we don't have a way to know. So we'll just move on to the next thing. Okay.
Okay, yeah, fine. So then I'll continue on with GitHub. So I'll share my screen. So before me starting with the code, I think all of you have the link to the GitHub, right? So you guys can access the code from there. So this is the GitHub link, github.com
Karthik,
slash by 21, and it was already shared by Umang in the chat. So you can directly go to the repository, and here I have the PPTX file. So this is the PPT that I used for yesterday's session, the day one session. And for today, like we have a notebook along with its the data file. So this car price assignment has the data required for the problem today. And
this
Also,
is the notebook that I have. So,
uh,
yeah.
yeah, Karthik, yeah, so the file is also in the description of the YouTube. So if people haven't got the access in the chat, they can look into the description of today's video also. The link is there for the GitHub.
okay, thank you, Umang. So here, there are two ways in which you can do it. So people familiar with GitHub can just fork this project. So that is one way you can do. And for people who are not familiar with it, who haven't used GitHub before and you're not familiar, you can also download the code. Okay, so here, if I go to this icon code, you have an option to download it as a zip file. So if you download this, the entire folder will be zipped and downloaded to your local, and you can use it. And the other way you can access it, you can go to this file, and once it loads, you'll get a label at the top saying, open in Colab. So you have it here, right? So open in Colab. So if you click that itself, it will open a Colab page where you can run this notebook. The other way is if you have downloaded the code, you can upload that to the Colab, and from there you can also run it. So I hope everyone is clear with it. Maybe if you have any difficulties, you can let me know. And so I'll move on with the session. So today we are going to see linear regression, right? So linear regression is the supervised machine learning problem where we have a linear relationship between data and we try to model it. And there are some assumptions that we make, before attempting linear regression. So they are one, that should be a linear relationship. Okay, so if there is no linear relationship, it means that you cannot apply linear regression. And second thing is homoscedasticity. So meaning the variance of residual should be same. Or I'll just put a plot here so that you can understand it better. Say you have a plot like this, and say your data point is like this. Say your data point is growing like this, in both the directions. Then that's called homoscedasticity. Okay, so homoscedasticity means your variance is high. So if I draw a regression line like this, here this point is exactly mapped, right? So the variance will be very low at this point. But as it moves on, since the graph is growing as the points increases, now the variance will be very high here. You have a lot of variance, right, between the actual point and the predicted points. So you have a huge variance here, but a small variance here. So when your variance is not constant across the distribution, so that's what they are saying. The variance of a residual is same for any value of independent variable. So when your independent variable changes, your variance should also be the same. If your variance is not same and it's growing or reducing, then you cannot apply linear regression. So that is the use case. And then independence. So meaning the input values. Say you have 4 columns in your input, they should be independent of each other. And finally, they should be normally distributed. So meaning you should have a bell curve of distribution for the data. And then, like I said before, there are 3 types of linear regression. Okay, so one is a simple linear regression, which is like your y is equal to mx plus c. Then we have multiple linear regression, where you have multiple columns. So here, if you see, you have x1, you have x2, you have so on till how many number of variables you have. So when you have multiple variables in your input, we go for multiple linear regression. So in real time, almost all the problems that you see will be like of multiple linear regression only. And then we have polynomial regression, where you have powers. Say like here, if you see, x1 is raised to the power of square, then cube, and then to the power of n, and so on. So when you have multiple powers, or when you raise the dimension of your input variable, that's called a polynomial. So your square, cubic, quadratic, all that, right? So they are called polynomial. And similarly here also, when you model your input based on a polynomial curve, they are called polynomial linear regression. So these are the three types. And for our use case, we are going to use a simple linear regression so that it's easier to understand. And simple linear regression, we are going to use the equation mx plus c. So instead of m and c, here c is replaced with theta naught, and m is represented as theta 1. Okay. And since this is the predicted value, I have denoted like it's going to be y dash. Okay. And with this, you can see like there are multiple graphs. Say this green dots are my data points. They can be modeled as y is equal to x plus 1 equation, and there are multiple lines possible. We are going to change the value. So when your m value is 0.5, and this is going to be the slope. When it is 0, this slope, and 1, this slope, 2, and this slope. And like that, when you have the proper matching, that's where you are going to stop your line and consider that as your distribution. And then I also talk about the residual. Okay, so here say this is a regression line that you built, and say like your dots, the black dots represent your actual data. Then the difference between your line and the dots is called the error term, okay, or the residual. So you calculate the difference between your line and the black dots to arrive at the error term, and based on your error term, you calculate the cost function, and you try to reduce the cost function to the lowest possible. So that's going to be your objective. So your cost function is defined like 1 by 2m multiplied by the error term. So error term is y dash minus y the whole square. So that's what we are going to do. And your goal is to reduce the value of cost function. And gradient descent is nothing where, but say your theta value is your slope, you are going to update it with the previous iteration theta value minus the learning rate into differentiation of your cost function with respect to the theta value. So that's what we do in the gradient descent. So in the next part of code, for those of you who are running Colab for the first time, like you can execute the cell in two ways. Either you can get into the cell and press shift enter, or you have the play button here. So if I run this, so this is the first time I'm running it, so it's asking me for a warning message. So if I run, so you can see that it is getting connected. So actually what is happening is like Colab is running your notebook on cloud. Okay, so when you connect to the Colab server, Google creates an instance for you in cloud, and establishes the connection between your notebook and the cloud instance. So that you also see the RAM and disk here, right? So you can see like what is its capacity also. And if you want, you can also use your GPUs for free using Colab. Say you have something to run, you do not have a powerful system, you can use Colab with GCP also in using the Colab platform. So now it has run. You can see like it took 1 second to run, and there are no outputs here. So I just import the required libraries. Matplotlib is for visualizing the graphs. NumPy is for processing the data. And then I import the linear regression model, and pandas again is for data analysis. So ideally, like you can get into machine learning only after you have a good basic understanding of Python, good understanding of data analysis and data visualization. So only after that you get into machine learning. Since we have planned this session today, like, I have already put the code in place for you, so your job becomes much easier, right? So you're just going to execute the cell one by one, and you're going to see what is going to be the output. So if I run this cell again, so here what I'm doing is I'm just input, defining two values. So y is going to be my target, x is going to be my input, just like we did it in the Excel. And when I plot it, this is the output. So I have a linear line like this. Then I'm initializing the hyperparameters. So I'm saying, like, my iteration is going to be 600. My learning rate, the alpha is going to be 0.0001. And theta is nothing but our slope, right? So initially I'm allocating my value of slope as 3. Okay. And I've done it 4 times because I have 4 data points in my input. Okay. So that's why I've given, like, my array as 4 element with value of 3. And then we have to define the cost function, right? So cost function is 1 by 2m into the difference, right? So that's what I'm doing here. So you can see, like, I'm calculating the inner value, and my y dash is nothing but mx, right? M here is theta and x is going to be my input. So here, if you see, I'm multiplying my x value with theta transform because I'm doing matrix multiplication here, right? So when you do a matrix multiplication, the rows in the first matrix should be equal to the column in the second matrix, right? So to do that, I'm doing the transformation, then multiplying by x, then the actual value y I'm subtracting from it, and then I'm raising it to the power of 2 because you have the equation as 2, right? So the same thing that I'm doing, and then I'm dividing this, summing up all the individual points I get from this line, and then dividing it by 2 into m. So m basically represents length of x, right? So by 2m. So that's what I'm doing in compute cost function. So when my m value is equal to 3, I have initialized it as 3, right? So at that point, my compute cost is going to be this. So I think I missed to run this. So I run it again. So when I run, so initially this is the compute cost that I'm getting. And then gradient descent algorithm, right? So where I'm going to update my m value based on the previous value and differentiation factor. So for that, again, I calculate the compute cost. Then I update my theta value to a new theta value by multiplying my learning rate and the compute cost. So the compute cost definition is this, right? So I take multiply my theta into x, divide from the subtracted from the actual value, then I divide it by the length of x, and then I use that as a subtracting factor for my previous theta value. And then what I'm doing is, like, just to see how the value is changing, for every 50 iteration I'm printing out the cost, theta, and the compute cost function. So when I run this, the function gets initialized. Then I'm going to run the algorithm. So for the algorithm, again, I given like alpha values, this iteration is this, I initialize the slope value, then I'm calling the gradient function. So let's run this. So now you can see that the cost was initially 315. Then after 50 iteration, it got reduced to 285. Then to 258, then to 233, 211, 191, so on. So at each iteration, you see that the compute cost is reducing. And if you see the m value, we initialized as 3, right? After 50 iterations, the m value reduced to 2.9975. Then it reduced to 2.87, 2.75, and so on. So it keeps going on until my cost value became 0.001. And my m value almost became like 1.8 for each of it. So then I print the g value, and if I plot it, so you can see that the line has moved closer to the data point. So if you run it for multiple iteration, initially the slope was given as 3, right? So your line would have been somewhere here when the curve started. But as the iteration started and optimized, your line came much closer to the data points. So by this way, we just implemented a linear regression just with Python without using scikit-learn library. So maybe I'll pause here for a moment and take up any questions that you guys have, and then we'll see the regression use case. Um, First question: how do you interpret a linear regression model? So how do you interpret is like, your linear regression model is going to tell you how much correlation each of your independent variable has on the dependent variable. Say, you have four independent variable and one target variable. Now, what is the impact of each of this independent variable in your target? So that is what you are going to learn from the linear regression model. And there's another question. This line could go up to the points, passing all the points. Okay. So here I just gave the iteration as 600, right? I did not tune it to the highest point. So, you have the code with you, maybe, the downloaded version. You can change the iteration and the alpha value and see how it is impacting the linear regression. So if you reduce it to 500 iterations, you may have a different curve. If you increase the iteration to 800 iterations, then you may have a different curve. So you can play around the number of iterations and alpha to see how it's impacting your linear regression. Okay. So that's all the question that I got here. And somebody's asking, what are the basic assumptions of a linear regression? So I think we covered it, right? Like there were four assumptions. One is like the data should be linear. Second is like, homodicity should be there. Third one is like what we saw. They should be independent of each other. Then finally, it should be a normal distribution. So we saw four assumptions. And there is another question: what is the use of Jupyter Notebook, and what does Google Colab do? So Google Jupyter Notebook and Colab are very similar. Okay, so if you see the structure and the usage, everything is the same. Only difference is Jupyter Notebook, you run it in local. So you install Jupyter Notebook in your local system, you run it, right? You have every setup in your local. In Colab, it's on server. Okay, you just need a browser. You are going to open it. Google creates a cloud instance where you are going to run everything. So the compute power is given by Google for free. So you are using Google server to execute your code.
So there's one question.
So in
This
that, I'll get to.
Yeah, Umang, please.
there's one question, one or two questions on YouTube. Should I take them up?
Maybe Umang, we'll take it up the end
Cool.
because we are also
Losing time, right? Like we have some 30 or 40 more minutes. So I'll continue with the example
and then finally we will take
of
it
the
up.
question.
Cool. We'll take it at the end then. Sure.
Yeah, thanks. Umang. So today's problem, the real set of problem that we are going to do is like a Chinese automobile company, Geely Auto, is trying to enter into US market. Okay, and they want to know predict the price point where they have to place their car. Okay, so that's the objective, and we are going to analyze the data and see like how we can do it. And before executing this data, you need to have the data. Okay, so in Google Colab, here you have the file folder, right? So you just have to open it, and here you have the upload button. So once you click on upload, you can upload the files from your folder. So here I have the car price assignment, right? So you need to select that and open it. And it just says like every time the environment gets refreshed, this data will go off. So that's what it means. So now I have the data ready and I'm good to execute. So for people who have opened it directly into the Colab, check if the file folder already has the data here in the folder. If it is not there, you need to upload the data. Otherwise, when you load the data, you may get error. So here again, we are going to import the necessary libraries, and then I'm going to understand the data. Okay, so any data when you start with, this is how you load it. So you use the pandas library and use the read CSV method because I have the CSV file. So I use the read CSV flow. So when I do it, I can also see the top 5 records by using the head command. So when I use a head command, I get the top 5 records. You can also see how many number of records you want. Say like, I give like head of 10, then I will get like, 10 records to be seen. So now I run it. This is how my data set looks like. So you can see, the car ID, symboling used for it, the name of the car, the fuel type, whether it's gas or petrol, so on. The aspiration, the number of doors in the car, what is the kind of car body, the drive wheel, the engine location where it is, wheelbase, car length, car height, car cube, and so on. So we have so many features. Next, what I'm going to do is I'm going to see what is the shape of my data set. So what it gives you, what is the number of rows and what is the number of columns. So when I run it, I get an output 205 and 26. Meaning there are 205 cars in my data set. And 26 means that I have 26 columns, meaning I have 26 features. So if you remove the car ID, it becomes 25. So I have 25 features. And then I describe my data set. So if I run describe, I get what is the count, mean, standard deviation, minimum, 25th percentile, 50th percentile, 75th percentile, and what is the maximum value. Say for example, I take this column, car ID. You see that minimum value is 1, maximum value is 205. So you have 205 records, right? So it's just a serial number starting with 1 and ending at 205. So you also have a unique 205, 205 different values in that particular column. So like that, by analyzing each of the column here, you can arrive at different information. Say for example, you take price, our target column. Now if you see the mean value, right? So the mean value is 13,276. So the average price of a car in US is $13,000 to 76. You can arrive from it. Similarly, the max you have, right? So the luxurious car that's available in the US market is priced at $45,400. Similarly, you can say min value is 5,118. So on. So like that, you can analyze each of the column to get more and more information from this describe statement. But I'm not going through each of them due to lack of time. Then we have an info method through which we can see the number of columns that is available, the total number of columns, and whether they have null values or not. What is the data type? So that we see in the info. Then the next step is data cleaning and preparation. So cleaning, why we need to do is say for example, here we have Alfa Romeo as one company, right? And we have Audi. Say somebody entered it incorrectly. Say instead of a car name they have entered the company, or instead of a company they have entered the car name. We need to evaluate whether it is properly filled or not, right? So that's what we are going to do. And in the data set, if you see, we have car name like this, Alfa Romeo Gallo, and we have Hardy 100 LS. So you don't want car name, you want to get company name from it. You want to know the brand name from it. So for that we need to do some data processing, right? So if you see, we have the company name, space, and then the model number. So here also the company name, space, the model number. Then we company name, space, model number. So we are going to split this particular column, the car name column, where there is a space, and then we are going to get the first value. So when you split by space, the first element that you get is going to be the company name, right? So that's what we are doing here. So if you see, what I'm doing is I'm taking car name and then I'm splitting it wherever there is a space. So I'm saying, whenever there is a space, you split it, and after you split, take the first element. First element is indexed as 0, right? So I'm getting the first element and putting it as a company name, and then into the data I'm adding it as a company name. So at the third position I'm adding the name as company name, and the value will be the value that I split and kept. So when I do that, here you can see the company name, I have the names here, Alfa Romeo, Audi. Now the the model name is removed from it. Then what I do is like I check the company names.
So when I give a unique, I get this list. And in this list, if you see, there are some spelling mistake, right? So Volkswagen is spelled as Volkswagen and also Volkswagen. And this VW is also Volkswagen, right? But they are, having three different values. Similarly, you have Toyota and then you have Toyota. There's a spelling mistake, right? So we are going to remove words like this. Okay, so what I'm going to do is wherever I have this word, I'm going to replace it as Mazda. Wherever I have this word, I'm going to replace it with this. So on. So we are replacing the names using this function. So that these are all the data processing that we do. So based on the data set that you have, you may have different problems. Okay, so you need to look at the data whenever you have a duplicate, missing value, or incorrect value, there is a typo, and all that needs to be fixed in the data processing stage. So this is what a data analyst does. So initially we had data collection, right? So we already had the data in CSV, so we did not look into data collection. We just took the data. Now what we are doing is the data analyst role, where you're cleaning up the data, you're processing all that. And then we are seeing whether if there are any duplicate values, and we got a null result, so there is no duplicate value. Then we are seeing what are the columns that we have. And then once you analyze the data, you go for visualization, right? So step 3 is visualizing the data. So what we are doing, we are going to plot different columns and try to get as many inferences as possible. So when I plot the car price, along the distribution, so this is the distribution that I get. So meaning like, you have the maximum number of cars available in this price range, right? Between it starts somewhere around 5,000, right? So this is between 0 and 10,000. So this point could be, somewhere like 5,000, and between, somewhere around 18,000. This is where most of your cars are. So you have a right skewed curve where majority of your population lies between 5,000 and 18,000 range. And this is box plot, which has the same meaning. So here you have the majority distribution between 5 and 18, right? So in this also, if you see, between 5 and 18 is where you have the biggest plot. So it's an alternative approach or alternative way of representing the data to find the distribution. And then we see about the... So here we are seeing about the companies. Okay, so based on different companies, I have plotted the histogram. So you see, like, Toyota is the top one. It has more than 30 models, followed by Nissan, which has around 18 models. So this is the exploratory data analysis that you do. So you have the data, you explore it by doing the analysis, and you plot different graphs, visualizations to get insights from it. And again, you see the fuel type. So you have the most of the car models that you have are gas models, and more than 175 of them. You have less than 25, which is like diesel variety. And if we go by car type, sedan is the most commonly used car. We have more than almost 100 models which are in sedan type, followed by hatchback, then wagon, and so on. So like this, you make multiple inferences. Okay, so the next graph you see by symboling, again you see the distribution, like 0 is the maximum, then it is right skewed. And then you have the engine type. By engine type, OHC is the most famous engine that is used, followed by OHCF, followed by this. And now company type with average price. So you have the company here, then you take the mean value of the prices of all the cars listed in that particular brand. So when we do that, we get to know, like, which is the least priced brand, which is the highest priced brand. So you can see, like, Jaguar is the highest priced brand available in US, and the lowest is Chevrolet, and everything in between. So you see, you know that these four are belonging to the luxury type. Then this could be, categorized as mid-range. This could be categorized as entry-range. So this will allow you to segment your data into, different bands based on the average price that they have. Then we see about, fuel type and the average price. and then about the car type in the average price. These are all done to identify which factor is influencing the price of the car. So now you see that based on the brand there is a huge difference in the pricing, right? So if it's a Jaguar car, you know that it's obviously priced higher, and if it's a Chevrolet car, you know that it is always lower priced car. So like that, you try to identify different parameters which will help you to model better. So you know that in your input, brand should be one of the important factor. If you see between diesel and gas, not much difference, right? So it means that your fuel type does not determine the price much. And then you have the car type. So this has a good difference. So you know that this should be one of the factors that you influence. And then we plot difference based on the number of doors. If you see aspiration, there's a huge difference. So you know that this should be an important factor considered for model building. Then you look at engine location, whether it's at the front or back. So there is a huge difference. So when the car is placed at the front, the price is very high, and when it is at the rear, it's very low. So that should be a very important factor when we calculate the model. And similarly for other factors. Then this is called a scatter plot. So far we were seeing histograms, right? So they gave you the distribution of data and inference of how they are impacting the target variable. Now what we are going to do is we are going to take two parameters and we are going to do a scatter plot to see if there is any correlation between them. So here if you see as the car length is increasing, price is also increasing, right? So you see dots at the lower end. As the car length increases, the price is also increasing. Similarly for car width also. So your assumption is that as the car length and width increases, the price of the car also increases. But if you see this car height, there is no relationship at all, right? There is no increasing or decreasing trend in car height. So meaning your car height does not determine the price of the car. And this has a perfect correlation, right? So the value is very linearly correlated between your curb weight and the price. So your curb weight is a very influential factor for determining the price of the car. And again, we plotted for different items. Now engine size also has a good positive correlation. This has a correlation, not very strong. This has no correlation. The stroke has no correlation. And this also has no correlation. Horsepower has a very good correlation between the price. This doesn't have. So like this, you do a pair plot or you do a scatter plot to identify which feature is correlating with which feature, which will help you to build the model. And then we are also creating new columns. Okay, so what we do is we merge 2 or 3 columns to create new columns, which are more meaningful than the raw column that we already had. Okay, say for example here we are creating a new column, fuel economy. Okay, and now in the data set, if you see, there are 2 different columns. We have city mileage, highway mileage. Okay, so what we are assuming is that 55% of the time a person will always use city, and for 45% of the time the person is expected to use highway. So that's the assumption that we are making, and based on that we are combining these 2 columns, the city mileage column and the highway mileage column, into one single column called fuel economy. So that's we are creating a new column, fuel economy, from 2 existing columns. So this is called feature addition. So we are creating our own new feature. So similarly, we are doing other modifications also. And then we are doing bivariate analysis. So bivariate analysis, you use more than or 2 variables. Okay, so here you have certain blue dots. You also have orange colored dots, just to compare between these 2. And here actually we are using 3. We are using RWD, FWD, 4WD, and we are seeing the distribution between them, whether they are forming a cluster, whether they have any relationship between them. And then this is another graph. Then finally, based on all the inferences that you made, you have listed down which are the important variables that are significant. Okay, so initially when we took the dataset, there were too many columns, right? So what we are trying to do is, like, we did all the analysis EDA to identify which is impacting and which is not impacting. So finally we arrived that, these are the columns which are important for us. And now we are going to create a model with all these parameter. And before that, categorical values needs to be converted into numbers. Okay, so for that we are going to use dummies. So what happens is, uh, say, we had fuel type, right? So fuel type, we had like gas and diesel, right? So now when you give it to a model, you cannot give gas and diesel, because the model knows just math, right? We are going to do all mathematical operations only. So you will have to convert all your columns which had text input into numerical columns. So that's what we do using dummies. And once you do that, this is the final data frame that you get. Okay, so actually what happens is, say, your gas will be replaced as 1 and your diesel will be replaced as 0. And say, your number of doors were like 2 and 4, that will be converted into zeros and ones. So that's what has happened. So here all the columns you see at the end has values of zeros and ones, right? So you are converting your input columns into numerical forms. So that's what we are doing through dummies. Finally, you have a data set where you have a target. So your price is your target, and everything else is an input field, and they have only numeric fields. So with that, you are ready to do your test, building the model. So before building the model, you will have to separate your input data into two halves. The one which you will use for training, and then the part which you will use for testing. Okay, so usually what we do is, we use 70% of the data for training and 30% of the data for testing, whether your the model is doing good or not. So for that, in scikit-learn we have a package called train, test and split. So here I'm saying my train size is 0.7, meaning 70% data to train, and test size is 0.3, meaning 30% of data to test. And random state is the way in which you split your data. So if you use the same random state, you will get the same kind of split when you run multiple times. So we have used a random state 10, and I'm splitting my data set into two halves. One is the train data set, the other is a test data set. Then what I'm doing is, I'm using min-max scaler. So what it does is, say you have a large values, right? So your curve weight is in thousands, and your engine size is in hundreds, and your car width is in around 60s, and here you all have zeros and ones, right? So when I give just this input to my data, my model may get confused, right? So I have ranges in thousand, I have ranges in hundreds, and I have zeros and ones. So all of them should have a relative number so that they have equal importance in my model, right? So to do that, what I'm doing is, I use min-max scaler. Now after applying min-max scaler, if you see, all the values are converted into zeros to 1. So you can see, all the columns have a value between 0 and 1. Now my model will treat all the columns in equal way. So there will not be any bias towards the higher value in my columns. So first I do a min-max scalar, then for my train data set, and then I describe it, then I see the correlation heat map. So this again gives you which factors are important and which are not. Then my target is my price, right? So what I'm going to do is, I take the price column and put it in my Y column, and everything else, so all the columns except the price will go into my X. So X becomes my input, Y becomes my output. Then I build model. So for building the model, I import the linear regression first. Okay, so from scikit-learn, I import my linear regression, and then these are used for calculating the outlier inference and also the evaluating the model. So I'll skip that for now. Then I import my model, then I'm going to fit it. Okay, and I have two variables here, x train and y train. So this is what we created, right? So y train contains the target, x contains the input. So I fit my training and or the input and the output variables. Then I measure, like, what is the RFE value. Then I'll show you. Okay, so we can skip this. And these are the functions I use for building the model and also checking the accuracy. Okay, so this function will print out in a neat way what is the accuracy of the model, what is the difference, and all that. And this will help me to build a model with just one single line. So I have the three lines that I've written here will keep on repeating for every model that I build. And what we are trying to do is, like, now we had around 14 16 columns, right? We do not know the impact of all the columns, which is out of that 14 or 15 columns, which is very important. So what we are going to do is, like, we are going to build multiple models. At each model we are going to skip one column. Okay, so the first I just use the direct data set. Okay, I just use the x train and y train, and I build my model. And automatically, since in the function I wrote lm summary function, my summary of the model also gets printed out when I build the model itself. So when I build the model, the first model, this is the accuracy that I get. Okay, the summary of the model is also written out. Then what I do is I remove one column. Okay, in my input data set, I drop one column and then build my second model. Meaning, like, I call the again function with my newer data frame. So I drop this 12, right? After that, I get like x train new. Now I use this x train new in my second model. So this is the summary for that. Then what I do is, like, I create the third model where I drop the another column. So in fuel economy is also skipped at the next step, and I create the third model. Then fourth model, fifth model, so on. So I build, like, 7 different models for the same problem. So here you get informations, like, which column is more important. So the model size is also decreasing, right? So if you see the previous one, I have like 6 columns here. And since we remove at each point, so if you go model by model, the number of columns keeps reducing. So here it's 5, right? So if you go one before that, there will be like 7 features, 8 features, and so on. What we are doing is, like, we are seeing the coefficient at each point, and whichever is having the least coefficient, we keep removing it, in an iterative manner. So then we analyze the models. So we created multiple models, right? So we analyze, like, what is the error term and whether it is being normally distributed. And finally, with the model that we created, we try to do prediction. So initially, like, we split the 70% data into train and 30% into test, right? Now we are going to use the 30% data which was used for testing. So I take the DF test. Again, I pop up the target column. Target column is price, right? So I put it in the Y data frame. Then for this df.test, whichever is left, I put it in X. And then I have to predict, right? So this is the model that we created, right? ELM, a linear model. For that, I'm predicting with the X test value that we did. So once I do that, I get the Y prediction. And now I know the actual values for Y prediction, right? So this Y test will have my actual labels. This Y prediction will have my predicted variables. And now what I'm going to do is I'm going to get the R2 score for between them. And this is the R2 score. And similarly, we can also plot it. So here what we are doing is, like, the further apart these points are, it means that, the model is trying to predict wrongly. So I have the Y test here, Y prediction here. They seem to be pretty good, right? Not much variance between the Y test and Y prediction. And also there are other ways in which you can do it. So after the final model is selected, we print out the summary, and in the summary you see the coefficient for each of the influencing factors, and also the different metrics. So that's how you do it, and this notebook is available for you to execute. So since we were limited by time, I know I just walked through the completely. Maybe after the session also you can run through the notebook to see how it is happening, and if you have any questions we can reach out to us offline as well. And some of the advantages of linear regression, they perform very good for linear data. And also in machine learning, say you have a problem and that can be solved in two different ways. You always go for which way is simple. Okay, you always try to have your solution simple. Linear regression is the basic algorithm that everybody uses for regression problems. So whenever you have a regression problem, the first algorithm that you will try is linear regression because it's very simple. And then it also gives you the coefficients. So in the model summary, you see the coefficients for each factor, right? So meaning like which factor is influencing and also like how much it is influencing. So that's the main advantage of linear regression. And disadvantages, like you will have to spend a lot of time in feature engineering. So more than model development, you will work a lot of time in feature engineering only. And then the outliers will have a huge impact. So when your data has a lot of outliers, your linear regression will tend to mess up your model. And then they are prone to noise and overfitting. And of course, we have other methods in which we can control overfitting, like lasso and ridge regression. They are not part scope for this training, but there are ways in which we can control overfitting. And finally, multicollinearity. So in assumption we made that all the independent variables are independent of each other, right? But in real world data set, it is difficult to do it. Say for example, in our example itself we had like gas and diesel types, right? Now you take the top speed. Now your top speed is not completely independent, right? Your gas models will have a better speed than your diesel models. So they have some kind of relationship, though we say them as to be independent variable. So when you have that minor relationship between the independent variables itself, it's called multicollinearity. So when you have a multicollinearity, your linear regression will suffer from it. So with that, we complete the notebook. So we'll open the floor for questions. Yeah, yes, please. So in the chat, I'm getting, in order to perform data processing like replacing the spelling mistakes, do we need to detect different spelling mistakes manually and then replace them? Okay. This question, is dependent on the use case that you work on. Say, you are working on a text analysis problem with English language. Now, English language has its own vocabulary, right? So you can use packages like NLTK or Spacey to import the English language vocabulary and auto-correct the typos in it. But when you go for structured data where you have codes or product name or the item name, abbreviations and all that, then the vocabulary will not work, right? So you have to manually look at the data and see if there are any error and accordingly correct it. And one simple way is like whenever you get a new data set, you can see what are the distinct values available in a column. So for each column, when you do that analysis, you will see like the unique values, and when you compare the values, you will get to know like if there are any typos that needs to be corrected. And second question is, justify the cases where a linear regression algorithm is suitable for a given data set. So justify the cases means like you want to know where it can be applied, right? So that means like when in general, okay, in real world, whenever you get a regression problem, the first algorithm that they would try is linear regression only. So, like I said in yesterday's class, like when you get a problem, you baseline the model first, right? For baselining, use linear regression for regression problems. So that's how it happens in the real life thing. And ideally, if you ask, like you need to check whether there is a linear relationship between your dependent and independent variable. So when there is a linear relationship, you always go for a linear regression. Okay. So, Umang, I've answered the questions from the chat here. Maybe if there are anything from YouTube, maybe you can read out. Yeah, and
One thing that I would
add is, like people take 3 or 4 months to get comfortable with machine learning. Okay, so in trying to acquire machine learning in a 4 hour session itself is a humongous task. So if you are feeling like you didn't get it completely, or you understood the concepts completely, that's perfectly fine. Please don't feel demotivated, or that you are not able to understand it completely, because we have directly started machine learning. We did not go through Python, data analysis, data visualization, and then to machine learning. So I can very well relate that for people who are hearing it for the first time, or seeing it for the first time, it might be difficult to grasp. But I would be happy that if you have got the concepts clear, like how linear regression works, what is a slope value, what is the intercept, why how we are calculating cost function, how we are doing gradient descent. If I'm able to grasp that, I think this session is a success.
Cool. Also, I'm just jumping onto the question. So, first question, which actually Arnav had asked sometime back, was please explain theta equals to np.array 3333 again.
So maybe I'll stop something, then I'll.
And also, Dhanesh has asked similar thing. Please explain why did you take 3 for theta? I think might be same questions.
Okay, so what happens? Maybe I'll talk about a little history also. So initially, when machine learning started, people were using multiple languages. Okay, so people are trying to solve machine learning problems using multiple languages. But Python won the race, and everybody started using Python. One of the biggest reason was that Python allows you to do matrix multiplication by default. Say like you have a matrix W, and say you have a matrix X, you can just write w dot x, and Python will do the matrix calculation for you. So that's one of the biggest advantage in Python. So what happens is like when you have a matrix multiplication, right? Now say I have input as y, okay, and I have like this is my input y1, y2, y3, and say I have x1, x2, x3. Now I cannot multiply this, right? So this is a 1 by 3 matrix, and this is also a 1 by 3 matrix. You cannot multiply, when the columns in the first matrix and rows in the second matrix are not matching, you cannot do a matrix multiplication. So if I have to do a matrix multiplication, I should have a matrix like 1 cross 3 and 3 cross 1. So this will match, and my output will have the size of 1 cross 1. So maybe this might take you to old times where you did matrix multiplication in your school days. So whenever you want to do a matrix multiplication, this condition should be satisfied. The columns in the first matrix should be converted into the rows in the second matrix. So when we do matrix multiplication in the formulae, you saw that x multiplied by wt, right? So w is your weight or the m, and we said t because we initialized our m as 3, 3, 3, 3, right? So now we want to swap it, like this is my input, my slope should be like 3, 3, 3, 3. So that's why we use this T there. So W transformation, transform. So now it became like 1 comma 3, 3 comma 3, sorry 3 comma 1, and this gets smashed and you get an output 1 comma 1, which is just one set. So that's why we use transform. And why I used 3 3 3 is like in the input I had 4 data points, right? Like I had 1 2 3 4 as input. In the output I had like 2 4 6 and 8. And in the multiplication, so I had 4 values here, 4 values here, right? So my slope should also have 4 values. So that's why I said 3 3 3 3. So otherwise I would have just said 3. Okay, so since I have 4 data points and for all 4 data points I have the slope as 3, I made it as 3 3 3 3. So I think that would answer your question why I made it 4, and that also explains like why we used a transformation.
Cool. Going on to the next question then. Uh, yeah. So, what is prone to noise disadvantage is asked by Arnav.
Noise means like say this is my regression line, and say I have data points like this. Okay, say during data recording there was a noise. So due to the noise, instead of this point, say this point moved here. Similarly, this point moved here and this point moved here. Now my regression line itself will have a different error rate, right? So noise is nothing but any difference in the data point that you have, right? So if my data point moves, my regression error will change, and when my error changes, I will adjust my line a little differently. Maybe instead of this first line, I may move it to the second line based on the noise. So whenever I have a noise, my regression line will also have an impact because of the noise. So that's why we are saying linear regression is prone to noise.
Cool. Now Sankosh has asked, the execution is saying that the CSV file are missing. How to link it?
Okay. Yeah.
I think before I started, I told you, right? Like in the Google Colab notebook, initially that will not be there. So let me go to the right page. So they have to go to the folder here on the left hand side, the folder icon. So they will get an option to upload the file. They need to click this upload to session storage and select the file. So once they upload, it will be listed here along with the sample data. Then they will be able to execute.
One second. Mukesh has asked, so this type of work done by data engineer or data analyst?
The entire cycle, right? So this is the work done by the data scientist. So here we did not do data engineer part, right? Like we did not do data acquisition or moving the data from different databases and all that. So we did not do anything related to data engineer. We did what a data analyst would do. We did what a machine learning engineer would do, and also a data scientist.
Cool. Few people have asked about random state. What is random state? Explain random state.
Okay. Say like
I have a input 1, 2, 3, 4, and 5. Okay. Say like I'm splitting my data into 60-40. Okay, meaning like now in this my training input could be 1 4 5, and this could be like 2 comma 3. Okay, now I train it, I test with this, say I get a model, and tomorrow I share this notebook with someone and they are also doing the same thing. Now when they do this 60-40 split, instead of 1 4 5, it could take 1 3 5, and my test model could be like 2 and 4 for a different person who is executing, right? Now they will also create a model. Now this model and this model, if you compare, will not be the same, right? This person will get a different result, I will get a different result, because my distribution changed, right? Like my train and test data changed between these two iterations. to avoid that, what we do is like we use a random state, and if I execute like random state equal to 100, and if I get this this 145 split, if I again use random state equal to 100, here also I will only get 145 and 2 comma 3. So by saying the random state, every time I do the shuffle, it will result in the same distribution. So if I execute the query and somebody else execute the query, they will get the same result.
So Shubhra has asked, can you kindly explain what is inference again? That is R square, F stats.
Okay.
Okay. Inference I will explain. Maybe if I have to explain everything, it may take a lot of time. So inference, what happens is, say I have x1, I have x2, I have x3, x4, then I have the y value. Okay. Now say I have my coefficient of x1 is 0.05. Say this is 0.1, and say this is minus 0.5, and say this is 0. So in inference, what we do is coefficient of x4 is 0 means that x4 do not have any impact on y. So that is what coefficient of correlation means. And if I say x3 is minus 0.5, it means that when my x value increases, my y value will decrease since the sign is negative. And how much it will decrease is 0.5 times of x3 value. And 0.41 for x1 means when my x2 increases, my y will also increase. And how much it will increase is 0.1 times. And similarly, my x1, when it increases, my y will also increase. And how much it would increase is 0.05. So now I make whenever my x1 increases, my y1 will increase by 0.05, right? That becomes my inference. And similarly, I can make multiple inferences for each of the variables that I have. And R squared is a common way. Say I have 4 variables and I want to calculate the accuracy for this. My R squared will give you the overall impact, and it's a measure of accuracy or performance. Okay, you can take it it helps to identify how good your model is performing. But how and how it is calculated, I think will be beyond scope of this webinar.
Many students are asking about attendance and certification link. Guys, so we are actually running a bit late. We have another session starting at 7 by Mr. Dipan Sahu. So we will switch to that in next 4-5 minutes. Okay. And at the end of it, we will have the scholarship test, which will have attendance link itself. So it would be next 30-40 minutes. I am sorry for that because learning is more important and we focus on learning part. So scholarship test would be happening in a while, and in that you will be getting the link. So that would be happening after Mr. Dipan Sahu's session, which we'll be transiting to in few minutes. Now going to next question, Diksha has asked, when the relation is non-linear, then which algorithm should we use or do we use?
Okay. So that's a very good question. Actually, when your relationship is non-linear, there are 2 ways in which you can do. Okay, so one is to make it linear and apply a linear algorithm. Okay, so how do I do it? Is you can project your data into higher dimensions. Okay, that's what we do in SVM. So at the start of the class, somebody asked about SVM, right? So in SVM, we have a concept called kernel trick. So in kernel, what we do is say you have a 2D data, you project it to 3D or 4D. So that data which is non-linear in 2D will become linear in 3D or 4D. So that's the way we do it. So that's one way. You convert your non-linear data into linear by projecting it to a higher dimension, and then you apply a linear classifier. The other way is you have other non-linear classifiers like decision trees, random forest, your KNN. So all them are good for non-linear as well. Okay.
So going to the next question, Utkarsh has asked, what cross-validation technique would you use on a time series dataset?
So this is a complete out of scope question. Like we never discussed about time series, and we never discussed about anything related to that, right? So I think I'll have to explain time series. Then the issue, then how to resolve it. I
Won't
think
have time for
we
that.
may not take this up.
So going to the next question then, Arnav has asked, what is bivariate analysis and can you also explain the use of dummy variables?
Okay, fine. I'll take the second one first. Say you have gender. Okay, yesterday also we used that as multiple example. Say I have male. Say I have female. Okay. Now what I can do is like I have to convert my text to number, right? So what I can do is like I can say my gender is 0, 1. Okay, where male becomes 0 and female became 1. Now, if I pass this data to my model learns from numbers, right? And if I take a number, one is greater than zero, right? Like one is a higher value, zero is a lesser value. And in scaling also we saw it, all the values were changed between 0 to 1. And so if I use a transformation like this, where male is equal to 0 and female is equal to 1, now my model will think that female is better and male is not better, because female has a higher value, male has a lower value. So to avoid that, what we do is like we create two columns: gender male, gender female. And say I have a male value. For gender male I will have 1, and for female I will have 0. And say I have female, then for gender male I have 0, and here I will have 1. So by doing it this way, by splitting my one column into two different columns, now all the values are either 1 or 0. So I will avoid this bias between these two values by splitting into two different columns. So this is what we do using dummies. So dummies function helps us to split one column into multiple columns so that we can use one hot encoding. So the other term that we use in data science is one hot encoding, where you split one column into multiple columns based on the number of categories, and then you assign it. So that's one hot encoding, and that's achieved through function called dummies.
I have shared our email ID, which students could send email to get the questions reviewed, because I think we are now going to shift to another session as given the shortage of time. So, Karthikeyan, anything to add? Should we conclude? Any thoughts?
Yeah, I'm good, Umang. So one update to the students is like, I also have my GitHub profile, and also my LinkedIn profile updated on GitHub, and everything is linked together. So you can easily find me, over LinkedIn. You can also find my other portals also. So you are welcome to connect with me and raise any questions on other portals. It's not like this session is done and you don't have a means to reach out to us or for any guidance. So you are always welcome to connect with me on LinkedIn and other platforms, and you can always reach out to me for any queries outside the session topics, or any queries that were based on these 2 day sessions. You're always welcome. So you can find my LinkedIn profile in the email, as also in the GitHub profile that was shared. In the about section, you can find the link. So yeah, you're always welcome to reach out to me.
Awesome. So everyone now has all the options. GitHub is there, LinkedIn is there, email is there. So I think you can reach to us, get all the problems solved in any which ways. And thanks, Karthikeyan. Thanks a lot for taking out the time. It was pleasure to have you, and the response we are seeing from students is amazing. So I think they loved the session as well. So it was great to have you.
Yeah, thanks, Umang. Thank you all the students for your time. And I see it in both ways. Like you have spent 2 hours yesterday and 2 hours today, and there are 1,000 plus students attending the session. So it's like 1,000 multiplied by 4, almost 4,000 hours of investment on these two sessions. So I'm also really glad and thankful to the students for trusting us and opting for these sessions. And I hope you also had a very good increase in the knowledge in these two sessions. And I also accept the fact that it's difficult to become proficient or very comfortable with machine learning with just 4 hours of training.
But I'm very sure that yesterday's session was very useful to understand how it works, the different roles and skills required. And today's session would have exposed you to a machine learning algorithm and a real world use case as well. So thanks for that, and hope everyone has a very good career and academic aspirations also gets fulfilled. So all the best for that, and thanks for the opportunity. Thanks.
So we are switching to the next session. Stay with me, guys. Hello Dipan sir, this is Umang here. I am co-founder at Elite Techno Groups. How are you doing today, sir? Can you hear me?
Yeah, hi, I'm good.
Great, sir. Sorry for the delay. Just finished another session. We are already live and without any further delay because sorry for keeping you waiting for 2 minutes. But yeah, great to have you. It's a pleasure to host you, given that you are among the forefront of helping institutes, helping engineering students be industry aware, and from there being with this session helping students to understand how education policies are happening, what's happening, and what students could do from here on would definitely be a great learning for all of them. So thanks again, thanks for joining, and without any further ado, I will be handing over the session to you.
So shall I start now?
Yes, sir. Sure.
And just give me a background that who are the actual participants, what is the composition of the participants?
So we have engineering students, most of them. Okay. The background is mechanical engineering students and computer science students. Okay. So it's kind of a mix because you would find around 40, 50 or 60% computer science students and others mechanical students. So mostly engineering school, college students we have.
Okay. So without making further delay, let me start my session on innovation and entrepreneurship. And my hearty welcomes to you all for today's session. And as I have given with the topic to speak on innovation and entrepreneurship, which will be more applicable and relevant to you all in your day-to-day life, especially when you are aspiring to become a good employee, or you want to start your own business and you want to employ others, and you want to generate more employment opportunity for our country and for our economy. In that case, I think everybody has to understand well about innovation and entrepreneurship, different aspects. Umang, are you telling something, or I'm getting some prompt? I'm getting some screen prompt from your side. Anyway, so okay, let's start with a common question, and also let's try to understand a bit in depth about innovation and entrepreneurship. I think in today's context, if we will go and ask to anybody that do you know innovation, do you know entrepreneurship, the answer will be yes. Everybody will, without thinking twice, they will say yes, I know innovation, I know entrepreneurship. But when you will go and check that what you know, then the actual things will come out. And because this word innovation and entrepreneurship are so common, now we have created this buzzword into a very common language and common word. So now I think even somebody knows what is actually meaning of innovation and entrepreneurship, but they will know that they have actually listened about this innovation and entrepreneurship word. You will find this innovation and entrepreneurship in all advertisements. You go for the things, they will always try to project that they are innovative, they are entrepreneurial. If you will go to any kind of a strategic sessions, or you will go to any kind of a in your classrooms also, they are this is a common word they are using while delivering. And most of the competitions, in majority of the competitions, innovation entrepreneurship is again a common word we are using. That means in the last 10 years, in India, everybody was now sensitized well, and also we have now familiar with the word innovation and entrepreneurship. There is no fear for getting this word into our ear, right? So now there is no difficulties in familiarity. But now the question is that if we are familiar with the word, but what is the familiarity or the knowledge on the application of the innovation and entrepreneurship? Do we know actually what is the importance of the innovation and entrepreneurship? This is the first question we have to ask. Okay, so please ask yourself, actually, do you have the knowledge on innovation and entrepreneurship? Do you have the are you aware about that? What is the importance? What is the actually utility of the innovation and entrepreneurship in individual's life, in or in to an organization, or to a startup or a company? The second question is that, are we aware about the process of innovation? One is know about the innovation, then know different aspect and the terminologies about the innovation and the concepts of the innovation and entrepreneurship. The second most important is the know the process of innovation, how each blocks, how each units or the each concepts are getting connected with each other, and it's creating a finally it's goes through it's create a value chain of wealth or wisdom. So we have to understand the first different concepts, different terminologies, and different what is the importance of the innovation. This is the first thing we have to understand if we want to utilize the innovation and entrepreneurship in our life. The second thing we have to understand, we have to make sure that all these concepts and terminologies, what we want to learn, or what are these associated with this innovation and entrepreneurship, how actually these are connected each other, and when it get connected each other, how these are generating values, how these are generating the output. So this is the second question we have to ask. The third question is that if this is the knowledge, if this is the process, then how to make use in the practice. That means how I will start involved in innovation and entrepreneurship. So I have mentioned there are 3 levels of understanding is required for an individual to make use of innovation and entrepreneurship in for their performance improvisation. The first level is that, no doubt, now you all are familiar with the word innovation and entrepreneurship, but you have to understand a background knowledge and the concepts associated with the innovation and entrepreneurship. This is the first level. This is the first level effort of should be all of yours. The second level of effort should be the process, that how these concepts are connected each other and it helps in generating value. This is the process you have to understand. Then the third thing is you have to make use in the practice by doing some hands-on practices, going through some experiential learning process to and develop some innovations and also start your business. Though this is 3 level of things, and now we have to check actually where we are now. Ask yourself, you are in the first level or in the second level or in the third level. If you are in the first level, that means you know what is innovation and entrepreneurship, but you don't know actually how to what are the processes and how to make use in your life, and you have not started any innovation or entrepreneurship activities so far, if you are in the first level, but you have a due respect and regards toward the innovation and entrepreneurship, you see the persons those are involved or associate towards the innovation and entrepreneurship, you have a special regard for them if you are in the first level. The second level is that you understand the process of innovation and entrepreneurship. So this, when you cross the first level, then you start putting your efforts and the time towards the process understanding. Then actually you develop a strong conviction, and also you have started inclinations toward the innovation and entrepreneurship, but you have no real-time experience with the innovation and entrepreneurship. But you understand that if this is the situation will come, then it will go through this way. So you have a broad understanding. Also, you are familiar with the process, that how the things will start from one stage to second to third to fourth, like that it will go. So this is the second level of understanding. Please ask yourself, I have given 3 levels of understanding. One is that first level of understanding, where you know the different concepts associates with the innovation and entrepreneurship. If do you have that, or you have crossed the first level, and right now you are in the second level. That means you know the different concepts and how to integrate and the connection between these concepts, and what is the flow of the value chain of innovation and entrepreneurship. This is second level. The third level is quite more mature understanding and the knowledge of individuals on innovation and entrepreneurship. And the third level of understanding is that personally we start involving and engaging in innovation and entrepreneurship activities. That means we started doing some action, and we started choosing a problem statement, and or we have started identifying the problem statement, then we started finding the solution for that. So this is the called third level. But third level of understanding has a different level of your kind of a your perceptions towards the innovations, because somebody will be in the very very early stage of the starting doing something. Somebody has progressed a bit moderately, somebody has progressed bit highly towards developing, like somebody is in the idea stage, somebody will be in the proof of concept development stage, somebody will be in their technology readiness level of 6 and above, somebody will be in the market demonstration of their products, somebody will be in the start of and doing the business out of this innovation. So there will be different level of involvement, understanding towards innovation and entrepreneurship. And as a student or as an individual, we have to think in a systematical way how to embrace this change of our market, which is requiring that behavior or that understanding within us. And innovation and entrepreneurship are now critical and very very essential element. Earlier it was like a very kind of a it was not essential element, but it was required, but it was not essential because market was not much competitive earlier. But now when demand and supply matching is quite not matching up with there is a high demand, but there is a supply is less and high, like in market there are job creators are the less, but there are job seekers are more. So there is a high demand and supply gap, right? Similarly in economics, this demand and supply, like when our companies are looking for the students or the individuals having entrepreneurship skill and the innovative skill and leadership skill. So when they are not able to find the such kind of students with qualities, then they negotiate with lesser salary with our student for the job. So in that case, actually, how we are going to match this demand and supply gap, and we have to develop the quality of innovation and entrepreneurship, so that when we'll understand the core technology or the core subject during our academic, that will complement and supplement the whole core with all these innovative and innovation and entrepreneurship skill set, so that when you will join any industry or job or any company, there you will actually behave like an entrepreneur, if not the entrepreneur, and you will start behaving like entrepreneur. You will lead the team, you will come up with lots of creative ideas, and that will actually enrich and enlighten the discussion, and helping the companies to come up with innovative products and the services. And gradually also you will also develop the leadership skill of people management. Then who knows that you will start leading the certain departments of the company. Then further you will also start your own company. So this is the gradual learning process actually every person goes through. And most of the entrepreneurs earlier, not now actually everybody is directly jumping into the entrepreneurship line, but earlier actually they go through these phases of first joining a job, then start performing better in that job, getting understanding on the different aspects and the people management, networking, finance management, and all this kind of marketing management skill set. And once they gaining certain confidence, and also they understand the business by closely watching the business processes with that company, and after that they leave that job and they start their own company. See, the Flipkart is actually it happened in exactly the same process. You can see all the major unicorns or the major startups actually what are the now currently operating in our country or even anywhere. Actually they are the spin-outs, or they are they have the experience, the founders have the experience of working with big industries and understanding and gaining the experience and the confidence by spending certain time of their early stage of their career, and that actually helped them to design and visualize a bigger business opportunity and getting into this startup career. So actually we are also expecting that certain people will go directly choose this path of joining a job, then understanding, then coming into the startup or the business arena. And few of you, those that have the good understand business intelligence and emotional quotient, they will directly start the startup career. So I have used two words. One is the emotional quotient, and second thing is called business intelligence. See, these two words are somewhat you can correlate with your software, but actually this is everything started with your brain. The first one is called emotional quotient. It says that how actually when you see something, when you come across through any kind of a situation, actually how you are connected with that situation, and how your interpretation and perception methods to drill down that situation and identifying the problems to come down to the solution stage. So actually your emotional quotient actually as a guiding factor to understand the customer's point of view, because in everywhere the innovation and the entrepreneurship is actually everything is it is actually revolving surrounds to the customer. If you understand your customer, if you understand your target group for whom you are going to develop the innovation, or for whom you are actually designing the solution, you are quite pretty sure, and you are picking a problem from that group, then it is very I think it's very easy, and also the process is quite also clear for you, that how where to start and where to end, or where to lead. So always you start with your target group, and your target, the problem identification should be from the target group, and you should know who is the target group from the day one of your problem identification. And problem identification should come from the target group, and then in the team you have to apply the design thinking tool to formulate the solution for that problem that you have identified from the target group. But in general, actually in our academics, this practice is not following. So what they are doing, they are finding a problem statement from the literature and they start working something in their lab, and after developing the technology, then they come and they check that who is the target group for their innovation. Actually there the mismatch happens, and the whole effort what the research scholars and our professors and our academicians they put towards developing this problem whole technology in the lab, and finally not matching with the customer's requirement or the customer target customer's need, there actually that product failed to reach to the market and remain in the lab only. No doubt they create the intellectual property, they file a patent, but it never see the market, and it completely a failure and also waste of money and the effort by the institute and the our intellectual mass, especially by the academicians. And we have to change this strategy, we have to change this approach, and we have to make sure that all the students or the faculties, those want to get into this innovation or research, they have to start with the problems, start with the target group, actually for whom it may be individual, it may be a group, it may be industry, it may be a specific segment of the sector, what it may be, but you know that who are the persons, which group is going to adopt the solution, and if you will develop if you will develop any solution. So first you have to study in depth with about this target group, their behavior, their skill set, their understanding, their problems, and you have to identify which problem that you can solve, and you pick that problem, you discuss in your team or individually, then you try to correlate with the already work done at the different level in different parts of the world and the country, and then you try to devise what your solution is going to be unique as compared to the solutions are already existing in different parts of the world, and that actually will bring the your uniqueness or the innovativeness, and then you build on your product or the services based on this solution that you have designed, what we call traveling from proof of concept level to the prototype level. Then once you reach the prototype level, then you have to go through a number of upgradation processes, starting from a lab scale prototype. Then you have to develop an integrated version of the prototype where you have to test in the similar environment in the market, and you have to demonstrate this to the customers, and you have to test that how it is going to perform if it will be put into a real situation, and you have to validate, you have to develop the features, you have to define the value propositions of your product and the innovation, and once it is done, then you have to get into the market enrollment or rollout in the market, either in the form of a technology transfer or through the startup. So there are two ways of transferring your technology or the innovations to the market once you reach this technology readiness level of 8 or 9. Once you reach 8 or there are different TRL level. I'm not going to talk about the different technology readiness level. There are 9 scale 1 to 9. There are 9 different TRL stages. Actually, the TRL 1 says that you are in a very conceptualization state, you are in the very ideation stage, whereas the TRL 9 says that you are ready to transfer to the market, or you are ready to start a business and manufacturing of that innovation or that product. So when you will reach TRL 8 or 9 or even at the TRL 7, then you can transfer your innovations to the industry, those actually need it, or you can start your own business unit or by establishing a startup. So this is the actually process of the prototype to the startup, and after the startup, actually there are process of business refinement, because you have to scale it up, you have to replicate this business model into different geographics, you have to take from our country to the other countries. So once you will start the business, then you have to focus on two things simultaneously. One is that you have to enhance your product portfolio. That it may happen that you will start with only one product and you will start your company, but to survive in long run, you have to see that how your innovation portfolio, your product portfolio will enhance. That means you look for the other similar kind of products or more innovations that will be added into your startup portfolio. And the second focus is that your existing products has to be further upgraded, and you have to bring the refinement, and also you have to add more values to the existing products. So there, at the product front level, at the innovation level, you have to do two things. One is that you have to bring more innovations to your startup portfolio, and also you have to improvise your existing products. But at the business level, you have to think that how you will scale it up, your business, how you will enhance, how you will amplify, or how you will add more customers, and how you will spread to the more geographics or different locations, and also how you will replicate this kind of business models in for other products. So this is the two way, and there are different ways that you have to think, and this is actually what the thinking strategy comes when you will understand the innovation, entrepreneurship, and intellectual property in a very well manner. That is the what I have mentioned about. There are three level of understandings, and actually you ask yourself in which level of understanding you are currently now in. And if you are in the understanding level of 1, then you have to through your putting the time and spending the time in the in your understanding the different concepts, you have to move from level 1 to level 2 to level 3, and in level 3 there are so many sub levels, and you have to again go from sub level 1 to 2, like that you have to go through. So this is actually learning process, and understanding the innovation and entrepreneurship happens in individual minds. And when individuals become innovative and entrepreneurial, then whole organization or whole company, the firm start behaving entrepreneurially. And when each company or each firm will start behaving and innovative and entrepreneurially, finally we can say that industry is innovative. And when each industry will get innovative, then we will say that economy is innovative, or the country is behaving innovative, and society is behaving innovative. So we individuals are the part of the economic, and our behavior, our understanding, our response, our action defines the whole country's economy. And when countries become innovative, then we will say that whole our earth, whole our globe is innovative, and we are progressive. And progressive means we always have to think constructive, and we have to utilize the opportunity, but there should be a ethics, and also the legal aspect should be there. We should not do anything, something is unethical and illegal, and that is the what business ethics says. And these two things you should always keep in your mind, that every action that you are going to do, or you will take in future or current, there should be a value creation for your stakeholders and not for the shareholders. So there is a difference between shareholder and the stakeholder. The shareholders are the persons, those are invested on your company, and they look for the profit only. They are not concerned for anything. They only look that they need money, or they need the profit out of the investment they made on your company. They are not at all care about the who is going to what is going to happen, or what the loss or it is going to create for the people those are going to use it. But stakeholders are the people, those are associates with your business, starting from the procurement of your raw material till the last person who is going to consume your product. And the entrepreneurs, the innovators, they think about the stakeholders, they never think about the shareholders. Shareholders will come in, those will like it, and they will bound to come into your company to invest. But entrepreneur, innovator, they have to always make sure that they are always thinking that value enhancement for the shareholders. And shareholder may be a raw material supplier, shareholders may be your employee, stakeholders may be your investor, stakeholders may be your distributors, they can be your collaborators, and also they will be the end consumers or the customers, those are going to purchase it. So please keep 3-4 things what I mentioned. One is the legal, whatever you will do the business, it should be ethical and should not be illegal. And the third thing is that focus on the stakeholders, not on the shareholders. So all these things you have to keep in your mind while you are thinking for or utilizing your academic skill set and trying to convert that into a business firm. And also I'm going to cover, there are three very, very important things you should not forget, and also it will help you to understand in better way this innovation and entrepreneurship concept. So consider that the first question is that attitude. So attitude and intention and the behavior, there are the three things at the individual of every individual. Actually it will decide that actually you are in the right direction or not, or and actually one is your knowledge level. Already I've explained for the knowledge level the three level of understanding: first level, second level, third level. But now I will say that how you are actually going to make it happen. That first level, what kind of your action is required, and the second level, what kind of action is required, and at the third level, what kind of action is required. The first level, what I have said, the first level is that your understanding on different concepts of innovation and entrepreneurship things. So to have an understanding, first thing is that you should have an attitude towards learning, attitude towards your innovation and entrepreneurship subject. So your attitude depends upon the what kind of information is with you. If you are not having complete information, if you have only knowledge on the parts and bits, your attitude will be also changed, and you will not have a confident on you, that you are not confident on your knowledge. And this is the where you will start swinging from one interest to the another interest, and you will be okay, and because you will start something, again you will get blocked, and again you will start swinging to another things, because you have no much in-depth knowledge about the different concepts. So first thing is that while you acquiring the different concepts, as you are in the first level of your knowledge on innovation and entrepreneurship, your attitude will decide that actually are you going to accomplish, are you going to complete the first level in successfully or not. So your positive attitude towards an innovation entrepreneurship, your learning attitude to acquire more concepts in depth, actually that will take you through the whole stage of innovation and entrepreneurship, and it will continue forever, right? It will not stop. But once you have the attitude towards positive attitude towards the innovation entrepreneurship, then actually it comes, the second level is called intention, because attitude when continue for long, it convert into intention, because you will now have a confidence that actually you have a good regard, and also you are feeling that you understand the different concepts. Then you will start developing intention that you also should know how it is going to connected each other, how actually these are the integrated, and how to make use in the how to apply in the real life situation. So this is the where actually the second level comes in. The second level is that understanding the process of innovation, understanding the process of entrepreneurship, and here the intention actually will define, intention will decide that how you will move from your understanding the concepts to applying the concepts in your in the real life situation. And once you will start putting your efforts, your intention will be get further confirmed, and also you will slowly move from intention to developing or inculcating that qualities within you, what we call behavior development. So you started with attitude, and your persistent efforts leads to the intention, and for your further persistent efforts lead to behavior development, and that behavior development is actually the third standard level of understanding, what we call action to be the actions that you are going to initiate and involve yourself in different innovation and entrepreneurship activities. Like you will involve in identifying the problems, you will involve in devising the solutions for the problems, and also you will involve in coming up with new products and the business opportunities for that product and the services or the innovations that you are you are developing. So there are three levels of knowledge: first level, second second level, third level, and there are three level of individual level, that is that attitude, intention and behavior. Actually all these three when combined and when have a good fit, and then there is a good match, actually that actually sail you through this whole process of development of innovation, establishment of startup and generation of wealth, and also will make you a complete human being with the values that I have explained, that is ethical, legal and also constructive, progressive mindset to make our country to make yourself wealthy, to make your society and environment and economic conscience, and making also the country progressive. This is the what is all about. I want to communicate to you all today, and I have some more things to offer you. That is now country is progressing and our country is targeting to become more innovative, and we are positioned third in one of as a third largest and third more dynamic innovation and startup ecosystem in the world. And in the global innovation index also we are positioned on 48th position in the global map. So in the global map we are progressing. But if you will ask me, actually have you materialized up to the fullest potential of our country? My answer will be no, because we have more than 4 crores of students are studying, and we have more than 8 to 9 lakh students, 9 lakh schools are there, and more than 51,000 higher education institutions are there. But actually if you will ask me that what is the percentage of the total institutions those are actually helping or actually have this innovation entrepreneurship and the students level, my answer will be only 1 to 2%. Only at the only 1 to 2% of the total students and our educational institutions, they are actually they have actually doing the innovation and entrepreneurship things, and remaining are only, again we are into the line of job seeking, and we are even not job seeking. Our students are also not acquiring the right mindset, right skill set for the to become employable. And this is the actual concern where our country is now facing the challenges. In one side we have a high population, in the other side we have the job sector is not growing, not growing as expected. And the third level is called our students, our youths. We have more than 60% of the youths are in the workforce, but they are not their job readiness level is not up to the mark. And this is the what is creating lots of unemployment rate in our country, and this is putting lots of development challenges for the growth of our country. And to address this one, the first aspect will be we have to speed up the job generation, and job generation will come from the small companies or the startups or the small and medium enterprises. So we have to first spread the culture of innovation and entrepreneurship to our academics, and we have to prepare, we have to give all this concept and understanding level and the individual skill set to prepare them to be to take that innovation and entrepreneurship as an alternative career option. And we have to put them into a practice of innovation and entrepreneurship, so that they will learn during the academic itself, and they will get out of the fear, and they will also boost the confidence of among the students and the faculties, so that they will start some business, or they will start behaving like an entrepreneur or entrepreneur during their post-study time period. And that will leads to generation, a creation of a special pool of intellectuals or youths, where innovation and entrepreneurship will be the key strategic approach to drive this to address this unemployment challenges, and drive our employment sector, and generating more jobs, and also creating more opportunities for others to get job. this is the what actually actually our country is looking for, and we have lots of expectations from you all, like students and the faculties. There are many policy initiatives we have started at Ministry of Education. One policy is called National Innovation and Startup Policy for our faculties and the students studying in higher educational institutions, and second one is recently done as a National Education Policy 2020. Both policies are actually innovation and research and commercialization of innovations, like that is startup as a core focus of imparting quality education both at the school level, also at the college level. And these two policies are being implemented by more than 2,000 to 3,000 educational institutions. But again, I said that this number is still less, and we have to reach to more than at least 50% of the total institutions should start looking that innovation should be the integral part of the course and curriculum, and entrepreneurship should be part of the their teaching and learning, so that students will get hands-on experience. They will also go through the experiential learning, and also they have to upgrade their knowledge on innovation entrepreneurship through lifelong, like through the continuous updating their knowledge on innovation through different certifications and the programs. Through this, actually, we can build a vibrant community of innovators, entrepreneurs, and an ecosystem at the national level. So with this, my session, I want to complete. I want to stop my session here. But finally, before I stop, I want to ask one question: is that when you are pursuing innovation or entrepreneurship, you ask the final questions to yourself, that are you actually focusing on a quality innovation, a quality entrepreneurship, or you are just trying to do the formalities and trying to just define that you are an entrepreneur or innovative. So there is a quite contrast, or the very strong difference between quality innovation, quality entrepreneurship, and normal innovation, normal entrepreneurship. So every time we are trying to justify that we are doing innovative, but ask, is it a quality? Is there quality, or is there actually distinction of the innovation that you are doing or not? So far, we will not shift from the generic version to a quality version. Then I think also there will be no much value we will generate, neither at the individual level nor at the country level. So with this, my best wishes to you all, and I believe you all have the right potential and attitude, skill set, and understanding. Only the thing is required that you have to sit down, and you have to think, and you have to align your knowledge building strategy, so that in next 1 to 2 years, that you will see that you will traverse from a path of being an innovator, then as an entrepreneur, then you have to behave like an innovator also as an entrepreneur. This is the what you have to think about, and you have to plan, and you have to develop a career plan for yourself for next 4 to 5 years. I think if you all will follow these things, and you will set your vision that in the down the line of 5 years you want to being a change agent in your society, that you will set the norms, you will set the standards, you will set the benchmark for the other peoples to follow, and you will be act as a role model for the others. So this is what all about today's session. Over to Allied Techno Groups, and we can take 5 to 10 minutes any questions if anybody will ask.
Dipan sir, so I'm just opening the doubts session also. Just give me a second, sir. So it was an amazing session, I should say. Taking from the point of view of how things work, how should anyone think to innovate, and then giving actual practical learnings in terms of thinking from product point of view, thinking from a person point of view. I think definitely these are some of the things which will help students be capable of not just looking at jobs, but definitely creating jobs. Because as you said, we at India want people who can essentially help the company grow. And as you mentioned, that we are improving in our startup rankings and the company is progressing. So with these kind of efforts, which company is taking, which country is taking, with the government pulling in things, so definitely a lot of expectations are also from the students as well. So with this, we have opened the doubts. Anyone asking any questions, please feel free to ask Dipan sir. So sir is in charge of innovation and startup department at the national level. So of course, you have a lot to learn, a lot to take inspiration from him. And these are the things, as being self-employed and taking things to the next level. This is something really important. This is what makes nations great, right? Startups, innovations, and all those things. So, guys, anyone any questions? Please feel free to ask. So we'll wait for a minute or two. If question comes up, we'll just take it up.
So the whole program will over tomorrow or what?
Yes, sir. So we have a final session happening tomorrow morning. Once there's a scholarship test to follow right after your conversation here, and people will be filling that scholarship test. And then we have a session by a machine data scientist who is working in US with abnormal security, and he previously worked with Walmart. So he is going to walk students through how machine learning projects work. So with that, we would be ending the session, and it was great to have a lot of dignitaries from AICTE, which was amazing. And I am sure multiple aspects were touched, from the career point of view to entrepreneurship point of view from your side, to giving students ideas on what is government doing, from Dr. Buddha's sides also. So I think it was a very healthy interaction for students, and the best part is I think students got the exposure which is required, because today the biggest thing which is missing is students not knowing what is there out and how can they take benefit of it. So when they get to talk to experts and folks like yourself and other industry folks who are actually working or making things work, they get the ideas that okay, this is also an option, okay, I can do that. So we are glad that a lot of experts could join in and they could address the students. So one question has been asked by Rushikesh: how to differentiate between a good innovation and a good idea?
Yes, good question. So I think it has two things, right? Good innovation and good idea. What is common? Good is common. Only the difference is that idea and innovation, right? So first thing is that if good is common, then keep the word good. Make sure that that good is happen at the good level, at the starting level also, right? Don't ask the good innovation at the innovation level. If your idea is good, automatically the innovation will be also good, right? So to make it happen, first thing is that and idea comes where? Idea comes from the problem. If you don't know the problem, then idea will not come. There are two type of ideas. One is that idea that you have the problem, and from the problem you are trying to find a solution. Like problem will come what? Like you are in your home and you watch your mom every day cook something, and someday you found that why your mom is getting always these difficulties, and you when you observe every day, and one day you have utilized your engineering skill or your other skills, and you suggested mom, this is the solution. You start doing it, and you will not face that same problem again and again. In advertisement also, I think one wire cable has done that, right? One in a very village, when a mother is trying to do the chapati, and by using the wooden stove, and his two years 2 years child came with a cable and say that you use this one and you do the chapati so that it will not drive. So that cable company was trying to communicate to the people, to the customer, is that see this cable has a things, it will not catch fire also. So this is how actually our students or our people, they, when they observe any problem and when they will come up with a solution to the problem, that is always good. That is always good because you started with the problem, and that's why it is always good. But what extent good, that I will tell later, but it is always good. Then what is not good? The not good is that you saw the dream in the night and next day you feel that okay, let's do it because I have enough time, or I want just trying to spend the time or the resources, and I want to show that I'm doing something. So when you driven by this kind of mindset, you came up with something overnight, like that you pick an idea overnight dream. So that kind of things are actually not good because it was not started with the problem. If you are thinking something that, then first you have to see that actually why you want to do it, why, what problem, whose problem, and how that problem is going to be solved. Actually, is it better than the existing one, or it is just lengthier than the existing one? So when you will try to ask these three questions, that this problem is whose problem, is it actually a real problem or not problem? Then the third question is that what is the solution, and is that solution is better than the existing one? So these three questions, if you will make sure at the ideal level, then it is always good. But when that idea will turns to the innovation, that is your product or the service, then you have to retain the good at the innovation level by connecting with the market. That means even though you will reach to the innovation level, again you have to ask the three questions: what I am developing, is it right? What I have planned and what I have designed, is it right? And is it actually helping? What I thought that it will help the customer, actually is it helping? That means again at the innovation level, you have to go to the market, or you have to validate with the customer. If customer will say that okay, you are right, I'm happy, I will be like to I would like to use it, or when they will give this kind of affirmative answers, then that means you are in the good innovation. So always you have to retain the good word with each and every level, but start with good. Always you will go in a good direction. If you will not start with good, you may divert, you may or may not get the good innovation. You got my point?
I think that is a very simple way but very powerful way of explaining it. So that was good. So there's another question which has been asked by students. So we have been asked why startups in India fail. 90% of startups in India fail within 1 year of launch.
Answer to this second question is also related to the first question. Majority of the people, they pick a business which is already exist, and they started just doing a small incremental innovations to that product. So when you start doing a business which is already exist, or something is just an incremental, then you are likely to get competitors in very short period. And there are so many people, there are so many companies, those are waiting for to get copy, and because they have the muscle power, they have the finance power, they have the richness, and they simply copy, and they will try to they will try to suppress you, right? So this is the one condition, that when your business model, when your product when your innovation is just incremental, the next level problem is your business model. When your business model is not scalable, when your business model is not sustainable, then when you are not making sure that you are targeting the right target group, when you are not focusing on the customer, then what you are doing, you are spending lots of money, lots of resources, lots of time towards a wrong customer group, or your strategy is not right thing, that also will actually leads to bankrupt in very short manner. So there are two levels I said. One is at the innovation level, when your innovation is not carefully chosen and it is just an incremental to the existing one, there is likely that you will get a good competitors, and they will suppress you because they have the money power and they have the network and everything. The second question is that when, even though your product is innovative, but when you go for the startup or business, and that business will actually face lots of challenges or implementation because it was not taken care of the sustainability aspect and the your scalable aspect. So always think about that. When you are getting into the market, your business, what is the model, what is the approach that you should focus, that it should be give you a sustainability, and also it will bring you the scalability. So these two things actually decide you will be survive for long or not, right? And that's why there are three type of fit is existing. One is called problem and solution fit. So problem solution fit you make sure in the at the innovation level. Then it's called market and product fit. That says that what the product you are going to cater to the market is also requiring that or not. That is called market fit. And the third fit is called business fit, the business model fit. That what the market, what the product you have identified, actually how this product will reach to the market, that is called business model fit. And when you will make sure that these three fit will achieve, or these three fits are ensured, then only you can say that you will survive at least 5 to 6 years or even more than that. If you fail in any one of these three, then definitely you will get out of the market in just 1 to 2 years. Money or the fund is not the factor of getting out. Factor is these three. So if you will ensure these three are there, then I give guarantee that definitely you will survive in the market, and also you will do the good business. Even though you will not get the fund from the any you will not get grant any from agencies.
Take one last question. Does your time permit that?
Only one.
Sure. Okay. So Pooja has asked, what if we have the idea for startup but don't know where to start? Means the procedure to start the business.
I think I've already explained, but let me give you in a very simpler way. Startup is something. Now don't think about the startup. When you either you are in an individual or in a group, always pick one problem statement. Start with very, very simple. Pick just one problem statement. Problem statement means you first define for whom. It may be an individual, it may be a group, it may be industry, it may be sector, it may be society. For whom? What is the problem? And that problem has some like what is the solution? And that solution should be effective. That solution be better than the existing solutions. First, you have to make these three. And I think you will definitely do it with your understanding, with your skill set, with your competency of your or the team. Definitely you will do it. Once you have done this, then the second stage is that solution has the business opportunity or not. Because sometimes solution has the no business opportunity. This is for societal, like NGO level or something like it for the government level, that things. But first you have to think that is that solution that what you are thinking or what you have developed or what you have designed, is there a business opportunity? Can you generate some revenue? That for that you ask another two questions. Is customer is going to pay for that? Is your solution is better than the existing solutions? If you will ask these two questions, you will get the business opportunity. Okay. So now I said two stages. The first stage is called focus on the problem. Take one problem statement and validate it and develop a solution. The second stage is identifying the business opportunity for the solution. Once you have done this, then start focusing on development of the solution into a product. That is technology, that is a prototype development or a development of product. Till that time, don't start the product. Only concept. Solution is the concept. When I say solution, it is a concept. It is not in the form of any kind of things. You have to say that my solution will be this. If this is the things and this is the solution, this solution is workable also. You have to make what we call proof of concept. So once you develop these things, then you go for starting your technology, and you make sure that you develop the prototype and demonstrate in the market or demonstrate in the real situation in just a very short period of time of 6 months or 1 year or maximum 2 years time, depend on the type of technology you choose to develop that solution, develop that prototype. Once you develop, then once you are half through, once you are in the tier technology readiness level of 4 or 5 or 6, that means you know that this product is going to definitely bound to happen, and definitely you will able to launch in the market. For that, there will be two ways. Either you can say that, okay, my capacity is on innovation, I will generate the intellectual property, and I will give the license to the other companies or other startups, and let them, I will only ask the license fee and royalty fee, and I will get the money in every year. That is also correct. And if you think that no, I want to start my own business, then you or your team have to register a startup and a company, and you have to take this product as one of the product, not whole of the startup. In your startup, this product will be one. Maybe in initially days it will be one product, but this is you have to start with that. And soon your team, because you know the whole process of starting from problem statement to startup generation and kind of things, that means you are quite versed with the process. Now soon you have to, once you start the startup, you have to think that what is the second problem statement. Okay, so now you have to give the responsibility to one or two team member, and they have to start focusing on that startup and the product, taking that single product that you have developed to the market, and your another team will start working on the second problem statement and third problem statement. And also it has to be go through the same process, because you are all gone through the same process, so it will be easier for you to go through the same processes. So next 2 to 3 years you should target that your startup has at least 1, 2, 3, 4, 5 such portfolio of the products or the services, which will make sure that if one product will not generate the revenue because of some reasons, second product will help you to generate some source of the revenues. So in that way, you have to manage a portfolio of the products and services, and startup will grow, and you have to think that how you will scale it up, the startup from this geography to that geography, to from this sector to that sector, from this country to that sector. So that will be a kind of thing. So this will be a regular phenomenon of product development, product refinement, business scale up. All the things will be part of the whole process. I hope I explained you the whole thing.
Sir, that was very elaborative. I think our students would definitely have understood it now and got the good understanding of things. So with this, sir, I would definitely express our gratitude in joining for the session, and student definitely would have learned it, and we would love to probably keep in touch wherever possible to get the student the visibility of AICTE, because AICTE is the organization which is making things happen, be it startups, be it education, be it whatnot. So talking and understanding from the horse's mouth is definitely the best thing. The way students would get the exposure of what is happening at India level, what is happening in the stage. So with this, thanks again, sir. Thanks for taking out time. And any parting word you would like to tell the students, I think we would have that. And yeah, that would be great.
Only I will say that you all are, I am also young and you all are young. So our roles and responsibilities to guide a nation to a next level where we can provide better health, better education, better environment to live, and also let live others wisely and healthily. So this is the only things we have to think about, and we should be the part of the change that we want to see in this world. This is the what only my message to my fellows. Thank you.
Hello everyone, sorry for the delays. Yeah, we were, of course, Dipan Sahu sir has taken time out of his busy schedule. He wanted to share things with you, and I do see a lot of comments, people getting frustrated in the chat. Really sorry for that. I know that there are few of you have work and you have spent 3 hours on that, but trust me, all of these things will help you going further. So with this, without any further delay, let me walk you through the scholarship test. I am going to share the scholarship test in the link here in few seconds. So for that, what is the procedure? So scholarship test is we are going to select one winner who is going to top the test. That student would have access to any ETG nano degree or internship course for free. Okay, that is up to 15,000 rupees of the program for free. And these are the programs which are even industry folks are taking up. So a great opportunity for you to learn. Everyone else would get a chance of 55% or 30% or 40% depending on their performance. So we would be giving scholarship to 125 students. Okay. Now, what are the programs? So Mr. Karthikeyan, who had taught you the session, okay, he has contributed in the development of the program as well. So he has created machine learning program. Mr. Ashish has created Python one. We have other experts who have created data science related and many other programs. Okay, so there are a lot of things which you can learn from the program to be industry ready, and all of the programs come with industrial learnings. Okay, so this this scholarship test is for 10 minutes. Okay, I will stop the clock exactly at 10 minutes. Right now 8:04 is the time. I have sent the scholarship form at 8:04. 10 minutes it will be closed. Okay, so try to fill it up. Okay, within 10 minutes your time has started now. Okay, and essentially, yeah, let's get started. Okay, any other questions you have, we will take it after the scholarship test. So scholarship test is out in the chat now. Okay, let's get started. So I will keep informing you on the time. Okay, so it's still 8:06. You have 8 minutes to fill in the scholarship test and get a chance to win. The eligibility to get the certificate is to complete your scholarship test. That's it. Link is shared again. You can click on the link and it would be there. Uh, 3 minutes have gone. We have 7 minutes left. So Sharvi, the last week's certificate should be shared within they might have already been shared. I think if you had filled the form, you have still not got your certificate. You could drop us a WhatsApp uh, by going to our website, getting to the WhatsApp, and telling us that you didn't get the certificate. But given that you have entered your attendance in the last week, okay, give your email ID on the WhatsApp. We will look on what happened and we will get back to you. Okay guys, 4 minutes are done, 5 minutes left, 5 or 6 more minutes. Uh, Attendance form Krupanka is with scholarship form itself. So let me tell you one more thing, that the result of this scholarship would be announced tomorrow, okay, in a session between 4 to 5. The details has already been shared with you, okay. The winner will be announced tomorrow, and then every other students we would be sending emails. So join tomorrow to understand what are our programs, on what programs the scholarship is applicable, for whom it is applicable, and all those aspects. Okay, so you can join us tomorrow at 4 to 5 p.m. to understand about who gets the scholarship. Also, don't forget to join the session at 10:30 a.m. tomorrow. Amardeep, it might be issue with your internet or something. Everyone else is able to submit it. So kindly check it once. It should be openable. So those who have completed the session, if they have any questions, so we would be having a session tomorrow 10:30 a.m. and we would be having scholarship result announcement and also a walkthrough of all our programs in that scholarship announcement tomorrow. Okay, so you would get to know the complete details of ETG programs, how they can help you learn the relevant things. Okay, and Yatish, the attendance link is the scholarship form link which is pinned. Okay, certificate you will get in next 4 to 5 days. Okay, so you have to complete the scholarship test and you will get it. We have less than 4 minutes left. Certificate will be sent to the students by mail. So the mail ID you have entered here will be sending you the certificate by that. Also, do not leave your Byte group because we are going to be sending a lot of information there. So you can benefit from there. So if you are part of a Byte WhatsApp group, stay there. Certificate will be given in next 4 to 5 days, as I told. If someone is joining now, so yeah, that's when you can get your certificate. Habib Sonu, the link of sponsorship test is already there. Okay, so you can test. You can fill it up here. Aditi, attendance is with the scholarship test itself, which is in the link here, and you guys have only 1 minute left to complete it. Okay, so yep, let's complete it. We are going to close the form within few minutes. If you have any questions in the issues or in the answer suggestions or anything, you could reach out to us on info@elitechnogroups.com. We will definitely be answering you. Okay, so 1 more minute left and we are going to close the form. So if you haven't submitted your form, please submit it as soon as possible. We are going to close the scholarship test right now. Okay, so if you haven't completed, please submit as soon as possible. Those who are done with the test, do join tomorrow's session, one at 10:30 a.m. and another one at 4 p.m. The 10:30 one is where you will be learning how machine learning engineers actually work in a company setup, and second is a session where you would get to know about the scholarship. So scholarship meeting would be at 4 to 5 p.m. where we'll walk you through all ETG programs. We'll announce the winners. Okay, and everyone else, yeah, please do join for both the sessions tomorrow. Okay, so we are closing the we have closed the form. Okay, so those who haven't submitted it, guys, the time is up because it's limited time you have to go. I would suggest join tomorrow's session because those are important. Manish, it will come directly via mail. We might not be able to inform on group because there are a lot of people who might not even have done the sessions and they would ask for certificates, which would be tough for us. So, but you will get it on mail for sure. Thanks, Akshay. A lot of students have shown love and appreciation for the sessions, and these are the things which keep us going. So thank you guys, thanks for joining in. We are great that you loved the sessions, you enjoyed it, so that's awesome. So yeah, you guys, you can leave who have completed. Do remember to join tomorrow morning 10:30 and tomorrow evening 4 p.m. Okay, link for 4 p.m. is already given in the Google form which has been shared with you. Okay, and everyone else, link for tomorrow's session is also there. Okay, so if there is correction in answer, please send us on info@elitechnogroups.com and we will verify and give it. Okay, so perfect guys. Any questions you have, any issues you have, you could ask it here and we would answer that. Okay, so anyone, anything, please follow, feel free to ask. Amisha has asked, is there step marking in scholarship test? No, Amisha, there is no step marking in scholarship test. We'll all get certificate, all those who have completed today's attendance form and yesterday's attendance and today's scholarship will get. Saurabh, if you have attended the sessions, if you have filled yesterday's attendance also, that is fine, no issues. Yeah, Tanisha, you can leave, you have attended the session, so that's great. Grishmita has asked, how many questions should we get corrected? So Grishmita, that's depend on how many students have got them corrected. So as per that, that would be answered. So yeah. Okay guys, I think then yeah, so for the campus ambassador certificates and for all the other sharing related information, we will be announcing the result from 1st or 2nd August to 5th August, somewhere between that, because we are going to verify everyone's data and then we will be giving other certificates or byte related announcements. Okay, so perfect, cool guys. I think I hope you guys had good learning. At Elite Technogroups, we always say keep learning, keep exploring, and keep growing. So that's all about it, and I hope you guys have a lot to take from here. So see you guys, take care, bye bye.